4 for the 10 days national level training program. As per our schedule, today's first class was supposed to be Dr. H.K. Virana sir because of his busy schedule. So he'll be taking class in some other day. Okay. So on behalf of Virana sir, his absence. Now I will say when I requested Shanaba Sabha to take the class seriously. So let me introduce today's resource person. So Dr. Shanaba Sabha started his career as assistant professor in 2009 at KVK Dakshina Kannada. Then from there, so 2011 he shifted to College of Agriculture, Shimoga. From 2011 to till date, he is working as entomologist as an associate professor. So he has visited more than 3 to 4 countries. Let me few I want to mention. He has visited 2 times India, America. So 2015 Florida and 2013 scientist award from insect environmental so for his flowing. So and the most important is so he is the first person to report the polar one from the Asian continent. That's a very big applause for Shanaba Sabha. So because of his vast study in the polar river, so he has been called for the resource person in neighboring countries, particularly Nepal and I think so Bangladesh, I don't exactly. And also Sim. So he was the first resource person to act as a resource person outside the favorite topic. Thank you, sir.
Thank you. Good morning to all. Thank you, Dr. Naveen, for your brief introduction. So, today I am sharing my experience with what knowledge I have with respect to the pesticides, mode of action of insecticides, and its classification. So many of the entomologists know what is the pesticides, what are all about pesticides. Many of the entomologists know about entomologists, the mode of action, classification of insecticides. It is just a kind of refreshing the information. Today I am going to deliver a talk on pesticide usage in India, then insecticides and the parasites classification and then mode of action. So pest in agriculture, pests like weeds, pathogens, insect pests, rodents, they are as a pest. So in agriculture, the insect pests are the major one. So pests are nothing but any living organism whose population increases to such an extent which will cause economic damage to crops and nuisance and health hazards to human being and his livestock is called as a pest. So here the agricultural pests, horticultural pests, then household pests, veterinary pests. So we classify these different insect pests, and to manage these insect pests we use the different IPM strategies. So integrated pest management, which include the several tools or methods to reduce the pest population. Here the objective is to reduce the pest population below economic threshold level. So that is very, very important. We are not completely eliminating the pests. There are different ways to reduce the pest population, like cultural methods, then physical methods, mechanical methods, biological methods, then biotechnological approaches to suppress the pest population, and last one is the chemical control. So chemical control, which include the use of pesticides. So We talk much about IPM, but majority of the farmers, they are using the pesticides. We say pesticides are the last defense in pest management, but pesticides standing the first line of defense in reducing the pest population or in managing the pest population. So pesticides, why we are using much of these pesticides, or farmers, they are using heavily pesticides. We talk much about biopesticides or biological control or non-chemical pest management. Yesterday, the sir was telling about the area-wide pest management by using the pheromones, particularly the sex pheromones, like the mating disruption technique, MTD. Okay, so in spite of that, the farmers are using heavily pesticides because they are easily available. Then second one is, irrespective of the environmental conditions, these pesticides or the insecticides works well. If you take the fungicides, they work very well under a very high humidity condition. But such environmental conditions which are not required, if you want to use the entomopathogenic nematodes in the soil should be wet, then only it works. There are several constraints associated with these biopesticides, but the pesticides or the chemical insecticides what we use, they doesn't require a specific environmental condition, easily available, and very important thing is they are very quick result will get within a very short span of time. The farmers, they need that one. Immediately after spraying the insecticide or any fungicide, he or she should get the immediate result. And the availability of these chemical pesticides. If you go to a remote village, you will get the chemicals. But it is not so with the biopesticides. And also one more very important, the constraint associated with these biopesticides is there is no big enough the factories or the industries producing large quantity of biopesticides, one. And also the second one is the quality of the biopesticides. Okay, yes, these many spores required to meet out the CIBRC recommendation. We don't have the labs. If you take the state like Karnataka, we have the SPTL, that is of state pesticide testing labs. They are evaluating only or testing the chemicals or the insecticides or the fungicides or the herbicides, but not the biopesticides. There are so many the limitations associated with the biological control and biopesticides. Because of that one, the farmers, they are using heavily the pesticides. So what are all these pesticides? Pesticides are nothing but the agricultural chemicals or the chemicals which are used to manage the pests. Those are called as pests. This is the definition given by Federal Insecticide, Fungicide and Rodenticide Act. So according to that one, any substances which are used for controlling, mitigating, destroying, repelling or mitigating any pest, so that is called as the pesticide. So usually if you take pesticide, pestis means pest, CIDE means killer. If you take herbicide which kills the herbs, weeds, insecticide which kills the insect, fungicide which kills the fungal pathogens. The class of pesticide, it ends with CIDE. But some of the chemicals which are not ending with the CIDE, but they are also considered as a pesticide. If you take the pheromones are mainly used for three reasons. One is monitoring, second one is mass trapping, and third one is the mating disruption technique, MDT. In mating disruption technique, we need to register under CIBRC, Central Insecticide Board and Registration Committee. That pheromone, it is not ending with the CIDE, but that is considered as a pesticide. Like attractants, repellents, chemostimulants, some of the groups of the chemicals we use, but they are not ending with CIDE, but they are considered as the pesticides. So here, I am dealing with the insecticides more with respect to its mode of action and the classification. Next slide. Okay, so why the importance of agrochemicals? So Norman E. Borlaug, the Nobel laureate, in one of the pesticide conference, he said the complete ban of agrochemicals used in agriculture might result in 50% reduction in the food grain production and increases the price of the commodity 4 to 5 times. So that is the importance of the pesticides. So I am not the saying use of more of pesticides, but wise use of pesticide, that is very, very important. So there are 4 pillars in plant protection with respect to the use of pesticides. One is the right dose, right method of application, right time of application, and the selection of the right insecticide or pesticide. So these 4 pillars are very, very important in plant protection. Next one. Okay. So according to the CropLife International, it is an non-profit organization. So many of the international and national companies are involved, the pesticide companies. So according to them, to develop a single molecule, say for example herbicide or insecticide or fungicide, it requires 11 years. From synthesis to commercial use, to bring that molecule to the market, it requires nearly 11 to 12 years, on an average 11 to 13 years, it is 11 years. And if you calculate the quantum of the money they spent to develop a single molecule, it requires nearly 500 to 600 crores rupees to develop a single molecule. So synthesis, then lab testing, then field trials, then registration, then coming to the market, it requires 11 years. So that is why the multinational companies are more actively involved in synthesizing the new insecticide or the new molecule. But the very few Indian companies now started their own R&D to develop the molecules. So DPPQS, that is the Directorate of Plant Protection, Quarantine and Storage, it was established in the year 1946. The main objective of this, the DPPQS, is to guide the central and state governments with respect to the plant protection. So CIBRC, that is one division in DPPQS. We have the different divisions under the DPPQS, like integrated pest management, which is promoting or the advising the farmers to go for the different methods to reduce the pest population. We have the regional CIPMs, that is integrated pest management, and quarantine, that is plant quarantine. Then CIBRC, Central Insecticide Board and Registration Committee. Then pesticide testing infrastructure, then locust control research, then pesticide monitoring and documentation. So among these, the 6 divisions, the CIBRC is very, very important, which is looking into the pesticides, with all respects of the pesticides, which is taking care. No. All agrochemicals, pesticides, which include your insecticide, herbicide, fungicide, plant growth regulators, rodenticides, acaricides, avicides, nematicides, molluscicides, which include pesticides. It is a broad term in which we have the different pesticide classes. Okay. So these are all the objectives of the DPPQS. One objective which is related to the pesticides is to ensure the availability of safer and effective pesticides through regulatory measures under the Insecticide Act 1968. And also monitoring of pesticide residues at national level. This is the main objective of the DPPQS, and in particular the CIBRC. If you look to the present status of the pesticides so far registered in India, as on 31/3/2024, 339 pesticides so far registered in India, which include all your insecticides, fungicides, herbicides, rodenticides, avicides, molluscicides, plant growth regulators, and nematicides, all that is of 339. So out of 339, more than 120 are the insecticides. Because in India, we consume more of insecticides. But if you take the world average, in world, the maximum consumption is of the herbicides. 50%, more than 50% the world, the consumption is herbicides. But with respect to the India, it is more of the insecticide consumption. Because India belongs to the tropical country, we find more of insect pests. That is why if you take cotton, we are spraying insecticides 6 or 7 rounds. Then the paddy we have, then pulses, vegetables. So we are consuming of more of the insecticides, 120, more than 120 out of 339 are of insecticides only. Then if you take the formulations, so 946 are the formulations, which include the sole as well as the combi products. So these formulations, like your solid formulations, liquid formulations, gaseous formulations, so 946. Out of 946, we have the insecticides, that is of 271. Say for example, imidacloprid is available in different formulations. Same chemical content which is available like FS, 600 FS, that is Gochu, 17.8 SL, that is Confidor, 30.5 SSC, that is Super Confidor, like Edmire, so 70 WS. A single molecule is available in different the formulations. So insecticides 271, that is of single molecule. Then 136, that is combination. Herbicides are also available in the market as a sole or the combi products. And the plant growth promoters, 26 so far registered under CIBRC, the formulations, and biopesticides, 103. So up to 2015-16, there were the molecules in the market, insecticide plus insecticide, fungicide plus fungicide, they are of having a different mode of action, insecticide plus insecticide. But so recently, we are getting the molecules of double combination or triple combination, which are of having insecticide plus fungicide, insecticide plus fungicide plus fungicide, insecticide plus insecticide plus fungicide. So one shot application which can reduce the insecticide, sorry, the insect pest and the disease. This is the first molecule from the Rallis, that is flubendiamide plus hexaconazole, which is available in the market as Origin. So first molecule of combination of insecticide plus the fungicide registered under CIBRC. After that, so many the molecules with the different combinations, insecticide plus insecticide plus fungicide, which are available in the market. If you look to the list, we find insecticide plus fungicide only, not the herbicide. So if you look to the pesticide consumption in India, in 1990s, it was around 71,000 metric tons. Now the present, the data available with the CIBRC, that is 22-23, it is 52,466 metric tons of chemical pesticides and 7,248 metric tons of biopesticides. Biopesticides like metrrhizium, pseudomonas, then trichoderma, all that one, even the neem-based insecticides, BT formulations, NPV, that's all 7,248 metric tons. So this is all the active ingredient If you take the insecticide or fungicide, so chlorpyrifos 20 EC, 20% active ingredient. So like that, the total consumption of pesticide, this is of active ingredient, not the commercial product. Okay. So in 1990s, I was mentioning about the pesticide consumption it was around 70,000 metric tons. But now, if you look to the data, the pesticide consumption again, it was a decrease in the trend because the, the molecules which are available in the market after 2000, the either insecticides or the fungicides, herbicides, which are of having a novel mode of action, and they require very less quantity. Say for example, chlorpyrifos we used to recommend 2 ml per liter of water. But if you take the insecticide like chlorantraniliprole or spinetoram or spinosad, just their recommendation is 0.1 ml or 0.2 ml, maximum up to 0.4 ml, not more than that. That is also one of the reasons why the pesticide consumption in India has gone down. And another reason was when BT cotton was introduced in 2002, initially we have not sprayed much of the insecticides. Before the introduction of the BT cotton, the farmers used nearly 10 to 12 rounds of insecticides to manage especially the bollworm, that is Helicoverpa armigera. So now, to manage the sucking pests and also the pink bollworm, the farmers, they are using 6 to 7 rounds of insecticides. Then on cotton also, the pesticide consumption is also increased in the trend. So the major reason why we are consuming less amount of pesticide is we are using much of the novel insecticides or reduced risk pesticides, or we can also say the soft insecticides. Insecticides or the pesticides are the pesticides, but with respect to the toxicity symbol, they are of having a blue or green toxicity symbol. That's why we call them as the soft insecticides or the soft pesticides. Yeah, biopesticides. So 52,466, that is of chemical pesticides, that is of the chemicals, then 7,248, that is of biopesticides. Yeah, sir, new generation pesticide. After 2000, so many of the pesticides which entered into the market, they are having a specific mode of action. So this is the same, the data depicted in the graphs. So 2022-23, it was less than biopesticides. If you look to the consumption of the chemical pesticides, commodity-wise, the cereals consume the maximum amount of the pesticides, especially among the cereals. The paddy is consuming maximum amount of pesticide, and also the maize. After the invasion of fall armyworm in 2018, before 2018, no farmer used the pesticide to manage any of the pests. Of course, we had the pests like the stem borer as well as the pink stem borer. The percent usage of pesticide before 2017, it was 0.1 to 1%. So after the invasion of fall armyworm, more than 99% of the farmers, they are using the pesticides. Across the country, wherever you go, at least the farmer use 1 or the 2 insecticides, 2 rounds of insecticidal application to manage the fall armyworm. That is also the farmers, they are using much of the pesticides in cereals. Then vegetables, as we know, the chili, cabbage, cauliflower, tomato, we are using much of the pesticides. Then pulse crops like chickpea and pigeon pea. So this is the commodity-wise, the pesticide usage in India. ಯಾರೂ ಮಾಡ್ತಿದ್ದಿಲ್ಲ ಮೇಡಮ್. Very less, very less. Huh. To manage fall army. Yeah, that's what I am saying. So 2 rounds usually. So when fall armyworm invaded in India 2018, farmers used 4 to 5 rounds of insecticides in Kharif season. In Rabi season, many of the farmers, frustrated farmers, they removed the crop when it was around 10 to 15 days old because they were unable to use the pest even by using the pesticides. Okay. Now the farmers, of course, it is like when any pest invades in a new area, it is a concept like boom and bust. So first 3 4 years we find very high level of infestation. It's peak damage we find. After that, the pest population falls because of the native natural enemies association will takes place, and also the climatic conditions, which helps in reducing the pest population. So if huh. Yeah, farmers to yeah. Yeah, it controls, usually its infestation starts from 15 days onwards. Then if they use the insecticides at a 10 to 12 days, we can kill the egg mass and also the neonates, the neonates from the egg mass. We can reduce. Majority of the farmers, they are using the emamectin benzoate insecticide, which we commonly call in Kannada like savige. Savige. If you go to 98% of the farmers, they are using emamectin benzoate only. But the two other molecules recommended by the CIBRC like corazin, chlorantraniliprole, and spinetoram, which is available in the market as a delegate. But they are very costly. Definitely the farmer needs to take to manage farm. No doubt in that one. No doubt in that one. So one good thing in India is the pest occurs, fall armyworm occurs when the crop is around 45 to 50 days. Up to that one we find its infestation. After that, once the leaf become hard, we won't find its much infestation. But in developed countries where the pest is native, America or Brazil, you find its infestation in crops also. They take nearly 12 to 15 rounds of insecticides. If you look to the China, they are taking 6 to 7 rounds of insecticides. Because it enters inside the cob, it is feeding inside. But in India, we are not finding it's feeding inside the cob. But majorly, it is causing damage to the leaf. Major, it's acting like a defoliator. Okay. Uh, and also in India, we are having good number of natural enemies. In the month of September, if you visit the maize field, we find the natural ephigetics of Metrrhizium reli, one of the fungal pathogen. Natural ephigetics we find in the field, 100% mortality. Okay. Metrrhizium, we should. Yes, sir, you are true. But the conditions, we need to have the sufficient wet in the soil and high humidity. That's all required for these fungal pathogens. When the crop is around 35 to 40 days, that is recommended. But in the initial stage, the prophylactic measures like seed treatment, like Potenza Dio, but no one is going for seed treatment. It is very cumbersome for the farmers because they are having the land holdings are very less. But the government of India or the private sectors, they are thinking, so seed treated materials they need to send. Okay, there are 2 3 more. Yeah, it is treated with thiram, madam, fungicide, not with the insecticide. Not with the insecticide. Yeah, yeah, not with the 20, 20, 25 days. We can skip one spray. One spray na hatu skip ಮಾಡಬಹುದು. Yes. Okay, so up to 40, 45 days only we find its infestation. And first spray we need to spray on the every part of the plant, and second spray we should concentrate more towards the whorl. So that is very, very important one. So this is the commodity-wise consumption of biopesticides. Again, the cereals consuming maximum of biopesticides, then oil seeds. Then the top 10 states in India consuming maximum amount of pesticides, that is of Uttar Pradesh stands first, then Maharashtra, then Punjab, Telangana. These are the states consume maximum amount of pesticide. So this is the 22-23 data. This is all what I'm talking with respect to this data is from CIBRC website, Central Insecticide Board and Register, DPPQS. Okay. Huh. Yeah, but it is not recommended one, but farmers they are using soap powder, soil along with insecticides. So one of my colleague that he brought that technique to reduce the fall armyworm population. So soil plus insecticide, that is of coragen, 50 ml coragen in 125 kg of soil per acre. Per plant we can put 5 to 6 grams of soil. Okay. So it should not be sufficiently wet. It is just like kind of, it is not fully slurry. It is just like what you can say, the ಉದುರಾಗಿರ್ಬೇಕು. Moisture ತರಹ ಇದ್ರೆ ಸಾಕು. How we prepare the poison bait to manage the armyworm. Like that, we need to prepare. It should not be too wet. Okay. So this is the data of from the CIBRC. So this is the consumption of top 5 chemical pesticides. So sulfur, maximum amount of pesticides. Among the pesticides we are consuming, that is of fungicides. So among the insecticides, that is of chlorpyrifos. Then among the herbicides or weedicides, 2,4-D, then mancozeb, then malathion. These are the top 5 pesticides, so consumption in India. So biopesticides, that is of Pseudomonas, then Trichoderma, neem-based insecticides, Beauveria bassiana, and azadirachtin commercial formulation that we are using as biopesticides. And these are all the pesticides which are banned in 2018. So 2020, 2023, even the monocotrophos banned, they are saying, but it is restricted to fruits and vegetables. Dicofol, Dinocap, and Methomyl already in the banned list. So in 2020, during COVID period, the proposal came from DPPQS to ban some of the pesticides, that is of 27 pesticides. So the committee headed by the TP Rajendran sir, former Assistant Director General of ICAR, the banning of these very conventional or the old pesticides, because they are of having the red and yellow toxicity symbol. The government of India is thinking to ban the old molecules which are of having the red and yellow toxicity symbols. So these are some of the pesticides which include the insecticide, then fungicide and herbicides. Still it is pending, not yet banned, these molecules which are available in the market. So these are the pesticides, then insecticides. So still that is pending, not yet banned. And these are some of the pesticides recently banned in 2023, one of the gazette, that is Dicofol, then Dinocap, and Methomyl. So this is all about the pesticides with respect to the India. If you look to the many of the developed countries, if you take I said the pesticide consumption in India is around 55,000. If you take the China, its consumption is 17 lakh metric tons. If you take the USA, its consumption is around 4 lakh metric tons. But the India pesticide consumption is just 52,000 metric tons. In spite of that, we are facing a lot of the pesticide residues. When we send our consignment to the European countries or the developed countries, straightway our consignment will reject because of high amount of the pesticide residues. But the major problem is we are not following the waiting period or the pre-harvest interval, PHI. So that is one of the reason why our consignment come back to our home state or home country. There is a gap between the time of spray and the harvesting. That is waiting period or the PHI. If you take every pesticide bottle, we find at the end of the column PHI or waiting period. Say for example in brinjal, chlorantraniliprole, wait for 7 to 9 days. But we are not waiting for 7 to 9 days. After 3 or 4 days, we take or harvest the brinjal and we take the produce to the market. Similarly, in majority of the commodities, we are facing the same kind of problem. So a few years back, so paddy was rejected because of high amount of that is tricyclozole, beam. Similarly, in same cases happened with respect to red chili and also the resins and also the pomegranate. We are not following the waiting period or PHI.
After 1939 is use of inorganic insecticides or inorganic means it refers to chemicals.
Inorganic insecticides and botanicals like sulfur, bodo mixture, like that, zinc phosphide, aluminum phosphide. Okay. Okay. Huh.
Especially in paddy, the time of harvest and the time of the consumption, there will be long gap.
Yeah.
Because it gets to be dried and then it will be milled, and by the time it reaches the consumer, the time is very long. Do you think still there will be pesticide residues in the rice that we get or consume?
Yeah, madam. But the thing is, we are not following the recommendation given by the CIBRC. So they say 2 ml per liter of water. We use 4 ml. When the pesticide dealer, he says 5 ml because he will get the foreign trip and gold, everything he will get. If you target this one, we will take you to Thailand. We will take you to Switzerland, 1 week trip. So it is happening and it happened initially in 3 states like Haryana, then Punjab, then Uttar Pradesh. Because of that, we are facing more of cancer patients. So one train popularly called as cancer train, which runs from Bathinda to Bikaner, from western part of the Punjab to the Rajasthan. So many cancer patients we find in those places. So that is there. But in developed countries, to spray the insecticide or pesticide, he should have the license. So, but we don't have strict regulations in India, and we are facing much of the pesticide residues.
And also whether fumigants have significant role in human health supplement, because in the millers they spray fumigants to avoid spore pesticide.
Yeah, that are also, yeah, they are also poisonous. Mainly they are using more of the pyrethroid insecticides. So relatively safer as compared to the organochlorines and organophosphate insecticides. So coming to the insecticide usage, then 1939 we all know the discovery of DDT. Then after the discovery of the Paul Muller, the DDT, then immediately one book came that is Silent Spring, written by Rachel Carson in 1962. She narrated the ill effects of this DDT insecticide on especially the aquatic organisms and the birds. And she called the psychiatrist by the many of the companies. She is not having any knowledge with respect to the pesticides. She is giving the false information about the pesticides. then filed a case against her, and in 1972, that discussion took place in the US Parliament, and in 1972, the thorough studies were conducted about the DDT pesticide and banned in 1972. But in India, it was banned on agricultural crops in 1984, I think. But it is under restricted use in India because this DDT is mainly used to manage the mosquito, to control the mosquito in India. So in municipal places or big cities, we are using this DDT. The only one company which is producing this DDT, that is of Hindustan Insecticide Limited, HIL. Then 1960, the organophosphates entered into the market. Then 1970, carbamates. Then 1980, pyrethroids. And after 2000, many of the insecticides which entered into the market, those are called as the novel insecticides or reduced risk pesticides or the soft insecticides. I said the extremely, highly, moderately, and slightly the pesticides based on the toxicity symbol, we can classify the pesticides. But the government of India wants only the moderately hazardous and slightly hazardous pesticides. These should be there in the market, and thinking to ban the extremely hazardous and highly hazardous pesticides. So with respect to the Crop Life International, I was mentioning a few slides back. So 11 years it requires to bring a molecule from lab to market, which requires 500 to 600 crores amount to bring a molecule. So the Crop Life International classified the pesticides based on the mode of action. So we used to classify the insecticides based on the mode of entry, mode of action, and chemical nature. And based on the chemical nature, we classify the insecticides like organochlorines, organophosphates, carbamates, pyrethroids, neonicotinoids, spinosins, avermectins, diamides, metadiamides. But this is the very standard classification internationally accepted, like the global resistance management. We have so global resistance management, you can download from your Play Store, and you can use this one to know the mode of action of the insecticide or herbicide or fungicide. So especially for plant protection, either entomologist or pathologist or the agronomist, kindly download from this, from the Play Store and use. You find like FRAC, Fungicide Resistance Action Committee, HRAC, and IRAC, Insecticide Resistance Action Committee. So this is a very good, what you can say, app. So very good app. We can come to know if this is the molecule, what is its mode of action. So please download and you can use. That is Global Resistance Management. This kind of symbol you will get, which include your insecticides, then herbicides or weedicides, and the fungicides. Yeah. So that is IRAC, that is nothing but Crop Life International. They classified like the FRAC, IRAC, HRAC, that is Herbicide Resistance Action Committee. That is another one is a Rodenticide Resistance Action Committee. So this is a non-profit organization which involves the research, extension, then also the education. Okay, so kindly download and use. So I am much interested to classify the insecticides based on the IRAC classification. It is well accepted by majority of the entomologists worldwide. So this is the IRAC classification. So according to this classification, we have a big classification of insecticides, particularly how these insecticides work on the physiology of the insect. So some of the insecticides which are acting on the growth and development of the insect, like chitin, which is acting on the chitin, which are acting on the ecdysone hormone, some of the insecticides which are acting on the juvenile hormone. In toto, the insecticides which are affecting the growth and development of the insect, so they are considered as the insecticides targeting the growth and development of the insect. Some of the insecticides which are mainly acting on the nervous system. So if you take the insecticides like the organochlorines, organophosphates, the conventional insecticides, what we call pyrethroids and the carbamates, they are mainly acting on the nervous system. But the newer molecules which are acting on the muscles, like the chlorantraniliprole, cyantraniliprole, flubendiamide, tetraniliprole, they are acting on the muscles, and that leads to paralysis in the insects and killing those insects. So collectively those are called as nerve and muscle targets, which are acting on the nervous system and also the muscles. When the paralysis which takes place, then there is no movement, there is no feeding of the insect. Okay, but the insect will live for 4 to 5 days, but it never consumes. Okay, so nerve and muscle targets. Then some of the insecticides, they mainly acting on the mitochondria. So respiration process, which inhibits the ATP synthesis. So they are called as the respiration targets. Mainly the acaricides which are available in the market, their main target is the respiration. Then some of the insecticides which are available in the market, they are mainly acting on the midgut, like the BT products. They are mainly the Bacillus thuringiensis or Bacillus sphaericus or Bacillus subtilis. They are mainly acting on the midgut, so they are called as the midgut disruptors. Broadly, so according to IRAC classification, we have the broad classification. And in each classification, again, there is a slight deviation with respect to the mode of action. If you take the nerve and muscle targets, that is, the first one is acetylcholine esterase inhibitors, carbamates and the organophosphate insecticides. They mainly inhibit the activity of the acetylcholine esterase enzyme, which is responsible for breaking the acetylcholine into choline and acetate. I'm not going in deep into the mode of action of the insecticides. In general, I am saying, that is also not required the deep into the subject. So acetylcholine esterase inhibitors, which include the carbamates and the organophosphates. The carbamates, like the insecticides like the aldicarb, carbaryl, then carbofuran, carbosulfan, methomyl, all these insecticides. But majority of the insecticides which belongs to the group organochlorines, already they are banned, except the DDT, which is under restricted use. Almost all insecticides banned its use on agriculture. So one molecule dicophol, which is very effective against the mites and also the sucking pest, that also in 2014 banned by the CIBRC. No insecticide recommended for the management of pest among the organochlorine, the insecticides. Earlier we used DDT, BHC, aldrin, dieldrin, heptachlor. So these organochlorine insecticides are called as the dirty dozens. because they are highly accumulate in the fat bodies of the human being or the higher animals. That is why the traces amount of these organochlorines we also find in the the mother's breast milk. Okay, so that is why these insecticides are called as a dirty dozens, and their half-life is very high. So that is why the government of India banned the many of the molecules. And the organophosphate insecticides. So actually during the Second World War, these insecticides came to kill the opponents. Actually they are considered as the nerve gases. Then these nerve gases later entered into the agriculture to manage the pest population. So among the organophosphate insecticides, so we are using now the insecticides like chlorpyrifos. Among the insecticides in India, we are consuming maximum amount of chlorpyrifos. So LA Hodrusa, wherever you go, so we get the chlorpyrifos insecticide, which is available in different formulations like granular, then EC formulations. Okay, so even 50 EC, which is also available in the market. So organophosphate insecticides, the other insecticides like malathion we are very commonly using in stored grain pests. Monocotrophos, that is also very commonly used. Phenolphos insecticide, that is also used. And one insecticide that is of acephate, a systemic insecticide which is very commonly used. But if you look to the CIBRC, I am talking with respect to the insecticide. Say for example, I was mentioning about waiting period or about the pre-harvest interval. One insecticide which is very effective against brinjal fruit and shoot borer, which gives 70 to 80% control. And another insecticide which is also equally effective in reducing the brinjal fruit and shoot borer, around 50 to 60% reduction. But where 60% reduction, here the waiting period is 3 to 4 days. The other molecule which gives 80% reduction, its waiting period is 9 to 11 days. Which one we need to recommend to the farmers? Yeah, but if you take the CIBRC, what their recommendation with respect to the waiting period, the molecule is very effective, no doubt in that one. But it is not possible to wait for 9 to 11 days. By that time, the fruit will over mature or overripe, and which is not preferred by the consumers. But the CIB also need to think. They give the big list of the crops, then pests, then the AI per hectare, then commercial molecules, everything. At the end, they give the waiting period or PHI. But they never think of the crop. That also they need to think and include which insecticide need to be recommended for brinjal fruit and shoot borer or tomato pinworm, especially in case of horticultural crops, that too the vegetables. That is very important one. I was mentioning about acephate. Acephate insecticide is also acting as the phytotonic. In North India, on BT cotton, the sucking pests are the major one. Among the sucking pests, the white flies. So one of the renowned entomologists, so in his blog, Dr. K.R. Kranti, you might have heard, the former director CICR Nagpur. So he wrote a very interesting article on the white fly. On cotton, the farmers, they use 6 to 7 rounds of insecticides. So ಊಟದ ಜೊತೆ ಉಪ್ಪಿನಕಾಯಿ, just like pickle, the farmers, they use the acephate insecticide with the other insecticide. So this acephate, it prolongs the vegetative stage of the crop. Instead of entering into the reproductive stage of the cotton crop, it is prolonging the vegetative stage. Thereby we find more of infestation of again the white flies. So in BPH management also, we should not recommend the methyl parathion insecticide. So such insecticides, the CIB RC has to give a clear-cut indication or instruction Yes, in paddy crop, these insecticides should not be used. Otherwise, it leads to the resurgence or the rebounds of the pest or recurrence of the pest in a very high number. So that is also lacking with respect to the. Then I was mentioning 2000, so many of the insecticides entered into the market effective and require very low amount of insecticide and relatively safer. I am using the word relatively safer, not 100% safer, relatively safer to the natural enemies, and they are very effective in reducing the pest control and gives the more effective control. And also the problem associated with the newer molecules is the cost. If you take the novel insecticides cost, it is very, very high. If you take the spinetoram cost, around 11,000 rupees per liter. Chlorantraniliprole, its cost is around 9,000 rupees per liter. If you take a broflanilide, which is available in the market as Brofria, its cost is around 13,000 rupees per liter. Novel insecticides or newer insecticides or the soft insecticides, they are very soft, relatively safer to the human being and the other animals, but the cost is very, very, very high. This is the major limitation associated with the novel insecticides. Otherwise, they are the best entities or the best tools in reducing the pest population. So newer generation insecticides, they are targeting not the nervous system. Along with the nervous system, they are also targeting the muscles. The conventional insecticides, I said, organochlorines, organophosphates, carbamates, and pyrethroids, they are only targeting the nervous system. That is why we found in many of the insect pests the development of the resistance. To delay the development of resistance, the companies or the scientists, they thought of bringing the new insecticides which are of having a new mode of action, targeting other than the nervous system. So this is a big list of the insecticides which are available in the market. They are not only targeting the nervous system. Apart from nervous system, they are also targeting the other systems like the digestive system, muscles, growth and development, and some of the insecticides which are acting on uh, the particular protein. Okay, so insect growth regulators, then neonicotinoids, then phenylpyrazoles, pyrols, pyropins, ivermectins, oxadiagens, spinosins, diamides, and metadiamides. So I said after 2000 new molecules like neonicotinoids. These neonicotinoids like imidacloprid, you heard about Confidar. So in developed countries, the neonicotinoids they want to ban because it is extremely poison to the non-target organisms, especially honeybees. They are saying question mark. So is it another DDT? Neonicotinoids are considered as another DDT. Especially they ban the use of these neonicotinoid insecticides, especially during flowering period. Completely they avoid or strict regulations they impose on the farmers not to use of these neonicotinoids. So these neonicotinoids, especially imidacloprid, which is a very common insecticide used to manage the sucking pest in more than 190 countries. The scientist, a Chinese scientist, Shinjo Kagabo, for the first time he synthesized a molecule in the year 1992. For the first time, Bayer company introduced in 1996. Now this insecticide, among the newer molecules, imidacloprid is the most widely used insecticide. That is Confidar, which is available in the market under the chemical name that is imidacloprid. So this is the classification of the molecules the mode of action wise we use to manage the pests. So among the chitin synthesis inhibitors, I'm giving very few examples, not all the one. The very commonly used one is the buprofezin, which is available in the market as a upload. Especially this is used against the mango leafhoppers and also the BPH, that is brown plant hopper in paddy. Mainly acts on the growth and development, which inhibits the synthesis of the chitin. So benzyl phenyl ureas, that is diflubenzuron. So this is also very effective against the cotton bollworms. Of course, we have the only problem with respect to the pink bollworm among the bollworms. So in the last class or yesterday, sir was mentioning about the refugia technique, growing of 20% non-BT seeds. The government of India in the last year so brought a concept that is called as a rib concept, refugia in bag. We cannot differentiate the seeds of whether this seed is a BT seed or it is of non-BT seed. So the government brought that is a rib concept, refugia in bag. So earlier we used to give 20% of non-BT seeds. Now it is a 5 to 10% of BT seeds, non-BT seeds in the BT seeds. We cannot differentiate. Earlier, two colors, one is of green and another one is red to differentiate BT seed and non-BT seed. Now it is of same color seeds. We cannot differentiate whether it is a BT seed or non-BT seed, especially the pink bollworm. Only we introduced BT cotton to reduce the damage of Helicoverpa armigera, which is giving, which has given a bread and butter to the many of the entomologists. And also we got many of the projects, crores worth of projects, especially if you go to US, the Harvard, we get one truckload of thesis only on Helicoverpa armigera. ICRISAT mainly working on Helicoverpa armigera. Premier institutes, if you go to CICR Nagpur, so mainly concentrating on the Helicoverpa armigera. If you go to Maharashtra, in all the universities, you find a renowned entomologist working on the Helicoverpa armigera. But now its infestation is reduced because of the newer molecules or the introduction of BT cotton. So we don't know when again it rebounds. Cotton area also reduced. If you take its damage also we find on red gram and chickpea. Even if you go to Gulbarga, its infestation is somewhat reduced. Gulbarga, a pulse bowl of Karnataka. Though when I was in primary school, my father used to bring 20 liters or 40 liters of monocotrophos in a barrel. Okay, in a cart he used to bring to spray around 60, 70 acres of the red gram. Now the time changed. We are having the newer molecules, just emamectin benzoate, 100 grams. So spinetoram, 100 ml, that is sufficient to cover the area. So that was the situation with respect to the use of conventional pesticides. Okay. So flufenoxoran, another insecticide, which is effective against the mites. So all these insecticides, novaluron, lufenuron, they are all affecting the growth and development of the insects. So neonicotinoids, I said. So neonicotinoids, why we talk much about neonicotinoids? So you might have heard CCD, colony collapse disorder. Neonicotinoids are the insecticides. They are highly soluble in water. If you collect the morning honeydew, you will get the traces of the neonicotinoid insecticide. So when the honeybee, worker bee, goes or visits the flower to collect the nectar or the pollen, so when there is a traces amount of nectar or pollen, when it goes inside the insect body, worker honeybee, it loses its memory from where it came from, which colony. In the middle, more chances of dying of the worker honeybee. So thereby, in a period of time, the number of workers bee reduce, then the colony gets abundant, then automatically the honeybee population is getting reduced. So not only in India, in many of the developed countries, that is the major problem associated with the use of the neonicotinoids. So these are the different neonicotinoid insecticides used especially to manage the sucking pests. So cyclic ketoenols, that is of insecticide plus caricides. Pyromesifen, especially it is used for the management of the sucking pests as well as the mites. So microorganism derived biorationals. So very commonly used, I said the spinosins and ivermectins, emamectin benzoate, then spinosins, which include the spinetoram and spinoside insecticides, very commonly used. These are all considered as the novel insecticides. They are acting on the glutamate gated chloride channels. So emamectin benzoate, very commonly used insecticide. So as you all know, the insecticides can be classified, or the pesticides can be classified. One is contact and stomach one, and another one is the systemic. So in between we find the translaminar. Translaminar, that is nothing but not a truly translocated insecticide, or translocated pesticides or insecticides which move from through xylem and phloem. Whereas translaminar insecticide, when you spray on the upper surface, the lower surface only become the poisonous. Not the whole plant will become poisonous in case of the translocated insecticides or truly systemic insecticides. So such insecticides are required to manage the sucking pests. Whereas some of the insecticides, they are mainly contact and stomach poison, but to some extent you can find the moment of the toxicant through leaf lamina. Those are called as translocated insecticides. Those translocated insecticides are like these spinoside and emamectin benzoate. Especially in grape ecosystem, these are very commonly used to manage the pests. Yeah, it's also effective for leaf miners, even thrips, especially in grape ecosystem which are having the blue or green toxicity symbols, such insecticides. Spinetoram, very commonly used, which is available in the market as delegate or radiant. And milbemycins, mites, pyrrole insecticides, that is chlorfenpyr, so against mites and DBM. Oxadiazine, so indoxacarb. Indoxacarb earlier it was available in the market 14.5 SC. Now it is available in the different formulation, that is 15.8 EC. So indoxacarb 14.5 EC, 15.8 EC. So very effective against the chewing and biting kind of insecticides. So waiting period, you can also find in each insecticide the label. And diamide insecticides, very commonly used insecticide, that is of chlorantraniliprole. So one, the formulation in paddy ecosystem, that is Fertera, very commonly used to manage the yellow stem borer. So wherever you go, the use of Fertera is very common. In India, wherever the paddy is cropped, so 4 kg per acre, so recommended by the CIBRC or the State Agriculture University or the ICR Institute. So mainly it is acting on the muscles. So when we apply the insecticide, the more release or excess release of the calcium, that leads to the muscle contraction, then paralysis, then death of the insect. So diamide insecticides, flubendiamide, different formulations which are available, then chlorantraniliprole, what I said, corazine, or the Ferterra that is of 0.4G, corazine 18.5 SC. So this is all the recommendation from the CIBRC. So just waiting period is 53. Though it is a very soft insecticide, we need to wait for 53 days. So phenylpyrazole insecticides like pipronil and ethiprole. So it is also a contact, stomach poison and systemic insecticides. So different formulations which are available. They are pipronil 5SC, granular insecticides, then WZ formulations, that is vegetable granules. Then neristoxin analogs, so synthetic analogs, cartap hydrochloride, that insecticide very effective against the yellow stem borer in paddy, which is of having the contact and stomach poison. Then this is thiocycline hydrogen oxalate, another insecticide, so which is available in the market as a vibrant, which is also effective against rice stem borer and leaf folder. So this is all about the insecticides and classification of these insecticides and acaricides. So briefly I covered, I have not gone into in detail about the mode of action because that is not required. Just if you know the very commonly used insecticides and acaricides among the farmers, that is more than sufficient. But the one thing is, whatever the insecticides nowadays which are available in the market, they are having unique mode of action, very specific mode of action. That is why these molecules are helping in reducing the serious pests or the major pests. So with this, if you have any queries or if you don't have any queries, so I thank Dr. Naveen sir for providing an opportunity to share my experience with the pesticides. So we have written a book also, The Pesticide Usage in Agricultural Crops. So written by me and the former Vice Chancellor of this university, Dr. M.K. Naik sir. So which covers the pesticide usage in India and world, and the CIB recommendation of the pesticides, again classification of these pesticides, the formulations which are available, and which formulations we need to use. Only FS formulation we use for seed treatment, not for any other purposes. And also the recommendations, toxicity symbol, so published in 2022. So thank you once again for all the participants and organizing secretary for the opportunity. Thank you.
Thank you very much, sir, for enlightening the different insecticide and their resistance levels at the different crops. So the sir, I think in the first slide, sir has presented as for the CAB regulation 2024, the list of the insecticide has been and the pathogens has been registered. So that is for the general usage. There is again CAB regulation for the drone usage. So okay, among the 1,736, they have been shortlisted. I think again that list is available in the website itself. If you go to the CAB and regulations, they have listed the molecules exclusively for the drones usage. Okay, so that means what they have enlisted those insecticides. So that can be used for the experimental studies or for the research activities in our fields for the different crops. So that's what, because the main objective of this class is their resistance level and the recommended dosage in crop specific. So that should be known. So that based on that, you can plan those molecules through the drone experiments. Okay, because as of now, there are no such studies has been done. I think it's a good opportunity where you can plan your experimentals related to different fields, maybe in horticulture or maybe in the different fields, pathologists, entomologists. So their resistance activities based on looking, so you can plan your experiments. So really it was the enlighten their phytotoxicity level and the resistance level what the sir has presented. Sir, on behalf of the organization, organizers, and also on behalf of the university and the participants, we wholeheartedly thank you for your nice presentations. I request Nagraj to hand over the certificate and token of love from the organizers. Thank you, sir. That I will present. So, any doubts? Okay, so there is a one announcement. So, yeah. The announcement is regarding with the tomorrow's visit. So received the program schedule from the RPTO, Clear Sky RPTO visit. Okay. So as for their schedule, okay, what they have sent the tentative schedule. So it may be modified based on that. So arrival at the Old Bangalore, that is a resort where they are exactly that Clear Sky registered office, that is corporate office is there at Bangalore. So they have sent the location also. So they told us to reach by 10 o'clock. We'll try our level best. Okay. Anyway, so that we'll be starting sharp by 5:30 here. So 10:30, we may reach by 10 or 10:30. Then there will be 15 minutes tea break. They have arranged tea and snacks. Then the presentation by Captain Gauravnath and Mr. Raghav. So who is experts in drone dynamics with respect to the fixed wings and multi-rotor wings. They will be presenting their role and how it will works, because now we have seen the parts and application rate. Now they will be presenting the drone dynamics, how it works. Okay. So then after their presentation, maybe around 11:30, we are departing to RPTO locations. From their corporate office to, it is almost a 30 kilometer. Okay. So they have sent the location also. There will be around 12:30 if it is. So then they will explain the RPTO site visit and flight demonstration by the Mr. Thana Rasu and Mr. Saad. So we'll be showing the different types of drones flying because we have AgriBot. I think they have nano, small, medium category, what the category and their principles in the flying areas they will be showing. Then after that, if it is complete in right time, so around 1:30 or 2 o'clock we'll be having lunch at Krishna Araman at Chikbalapura. Then we'll be departing to our venue. Okay, on the way, we can have our unofficial visits. We can plan accordingly because we'll have time so that we can reach here by around night for the dinner here only. Okay, fine. This is the tour program I have received. So accordingly we can plan. Okay, fine. So that for that purpose only we can leave a little bit early so that we can reach it. Okay, fine. So we can break for tea, then we'll reassemble in 10-15 minutes. Sir? Yeah, that I will share it in the WhatsApp group. Sure. Thank you. Okay, once again, good morning to all of you. With related to the topics on the main core title, that is potential, standardizing the operational protocols. Okay, so in that regard, yesterday I think Srinivas has presented some of the case studies with related to the cotton and as well as paddy. Those trials are sponsored trials based on that he has varied the molecules. But when you come to the standard operating protocols, there are several factors to be considered for developing the standard protocols. In that cases, how the field experiments to be designed, how it is different from the regular field experiments, and what are all the criteria to be considered for taking out the experiment. For example, if for generally what we will do for the spraying of the any molecules with respect to the knapsack sprayers or the power operated sprayers, we'll calculate only the dosage based on its logarithmic scale. Okay, that is what the sponsor trials will be. They will be giving one after they evaluated in their in-house projects. So they will be coming out with one recommendation. Okay, for that they will giving 1.5 to another one is for high level for the toxicity. But in these cases, we need to consider the flight height, speed. Flight height means above the crop can be how much we should consider, when we have to spray, okay, and how much of water volume to be considered. Okay, those are all the some of the criteria we have taken. How much of flight speed should be considered? For example, if you want to take the 3 meter per second, 4 meter per second, so there might be different factors, okay, or the different variables can be taken for developing the standard operating protocols. In my experiment, which is a externally funded ad hoc projects, where we are developing the standard operating protocols, especially for our university jurisdiction area. Okay, because when it comes to for the field condition crops, here the major crop is paddy, because we have the assured rainfall one thing, because many of the regions, particularly our university jurisdictions, having hilly region, coastal region, transitional, and also we have southern dry zones. But wherever southern dry zone also and central dry zone is there, where that is the only district where we are not having the command area facilities for the rice crops. Otherwise, all the 5 districts would be Mangalore, Kodagu, and as well as Davangere, Shivamogga, Chikmagalur, and Chitradurga. Except Chitradurga, all the 6 districts, the major field crop is paddy. Then we have proposed in such that because we are having more than 4 lakh hectares. When you proposed this project for standard developing operating protocols, we thought let us not develop the standard operating protocols for the regions. We're developing for only one experiments. Let us develop all the standard operating protocols. That means herbicides, fungicides, insecticide, and mineral nutrition. So that when we are giving the recommendation to the farmers, it should go in a complete package for a single crop. Okay, so if you want to use the herbicide, what is the dosage? If you want to go for insecticide, what is the usage? If you want to go for this fungal or the diseases, what is the dosage? If you want to go with any foliar nutrients like nano urea, XYZ, whatever it may be, so foliar urea, what is the dosage? So considering we are concentrated only one crop, since from last 1.5 years we are working, 2 seasons is completed. So, but I am not disclosing the results. Just I will tell what we did. So we are not disclosing the results. Then parallelly, from last season we have started for the 2 crops. Again we have started for the soybean and one for the maize. Okay, this year, because next paddy, the second major area is maize we have. Okay, for the maize also we have started developing the standard operating protocols. Then for the second, we have soybean is the major area, upcoming area in our university jurisdictions we are developing. So we thought to develop one more with respect to the plantation crops, that is in Areca. So right now we are through with the paddy, because now we know what are all the parameters or the factors to be considered for developing the SOPs. I think this might be helpful for you people. So design of experiment where we got fund from the NABARD of around 30 lakhs, so exclusively for developing the standard operating protocols with respect to the drone-based agrochemicals. Okay, so that's a funding agency. So we have not like in other experiments, but here we have a project monitoring committee team. every quarterly they visit, okay. They will have the review meetings, what is the progress, okay. So DDM, Deputy Director Manager of NABARD, who is the background of agriculture, so he will be reviewing, and the progress will be reviewed at quarterly, and the monthly progress will be updated, because once the progress is performing better, then only they can fund for the second phase and as well as third phase. As of now, I think the first off in Karnataka, we are the first with respect to the developing SOPs is the continued project in NABARD. Because usually NABARD funds for rural infrastructure and all those things. They are entering into the research field also with innovations. If innovation is there, definitely they will fund. Other all other institutions, they will fund. If you go through the NABARD website, so there are, I got funds under FSDF, that is Farm Sector Developmental Fund and Farm Sector Innovation Funds. Okay, we have Rural Infrastructure Developmental Funds, Farm Infrastructure Developmental Funds. You have to go through those, the content. So based on that, you have to prepare your project proposal. This is the one wing. So even I submitted for the, prepared for the DBT. Now for the ARECA, we have planned to submit it for the DBT. They also funds, but you should see the objectives, what they are, for what purpose they are funding. No, they have their own objectives. They have their own objectives. In NABARD, only the farm innovations, they have funds for the research. This is for 3 years. First 2 years, we'll be developing the standard operating protocols. The developed complete package to be demonstrated in the farmers field in each district at 20 acres. From herbicide to mineral nutrition. Third year. Once, because we are the body, because the university, we have the scientific body at ZREP and annual, will be presenting, will be coming out with the packages. That package will be approved, and that will be evaluated in the farmers field in all the districts, the complete package. No, research station. I will present all the, where exactly we are conducting, what are all the experiments, what are all the experimental treatments, so that you can formulate your treatment based on this one with respect to the crops. Okay, this is the, she's NABARD DDM, Sangeeta Karta. She's from basically Kerala. So before, see, particularly NABARD, the experimental. We have formulated the 4 experiment. I have a team. I cannot say I'm the only person. We have a team. For agronomy, we have 3 persons, Dr. Changodar, myself, and Dr. Shilpa is there, and Dr. Suresh. And also we have entomology, Dr. Krishna Reddy and Dr. Sharana Basappa. We have drone team. And for the pathology, we have Sahana Banka, and Dr. Sachin is also in entomology. So these are the team we are having, doing for this SOP, because once we want to develop all the standard operating protocols, the first agronomic trial we thought to have bioefficacy of selective broad spectrum pre and post emergent herbicide applied through agriculture drone against weeds in transplanted paddy, because the main targeted crop is transplanted paddy. That experiment is conducted at the AHRS Katlagiri. Again, it is a command area located in Davangere district. Then entomology trial bioefficacy and phytotoxicity effect of broad spectrum systemic and contact insecticide applied using the agriculture drone against insect pests in transplanted paddy. Again, this experiment in Chikmagalur district, that is AHRS Bhavikere. Again, it is the command area facilities. We have very good command areas on our research station. Then pathology, we have bioefficacy and phytotoxicity effect of broad spectrum systemic and contact fungicides applied using agriculture drone against fungal diseases in transplanted paddy. These, again, I will tell you how this experimental, when you are executing, again, the problem is we have taken the location in such that where the, particularly in Katlig area, that is almost end area, that means almost command areas, tail end part area. So there little bit of alternate wetting and drying will be, chances are there. So that's why the weed population will be good. Whenever the alternate wetting will be there, weed populations will be varied. So that's why we thought that is the best location to conduct the experiment. Then for the Bhavikere, which is very close to the dam, that means hardly perpendicular, if you take hardly 2 kilometers a day, that's all, 2 kilometers we have. We thought where the RH relative humidity will be good. and even Honnaville research station. It is almost a 5 kilometer perpendicular to those dams. Relative humidity will be good. So when the humidity will be good, the pathogens and the insect population will be higher. Considering that, the location also we have selected like that. But unfortunately, in some of the cases, what happened in our field condition, we have targeted insect management. So during that time, we have not noticed the insects. We have not noticed the pathogens. During that time, what we will do, we'll nullify that treatment. That's not an issue. That's why the 4 seasons why you are doing means we can, because just like missing plot technique, what we are doing, that's what. So 1 year if it is lost means no issues. Second year, no. Third year, fourth year, like that. So we'll be get the average, what are all the pathogens or the insect will be noticed. So selection of the site with respect to the crop is. So we have taken the variety which is a sensitive. That is, it is not a resistant crop, it is a sensitive to those pests and diseases that we have selected. Then again for evaluation of performance of conventional and agriculture drone sprayers, nutrient element especially for the rice productivity and transplanted, which is in Udupi districts, where the Rabi area we have very good. So again we have taken. So all the 4 experiments completed 2 seasons. So this is what the drone experiment, the drones what we are using. The swath width is 3 meter. We have kept the standard. Okay. So you can see the crop height, the spraying height. It's me only. It's a crop height. The spraying. If you want 1 meter, 2 meter, 3 meter, we can calculate workout. For our horticulture crops, needs a little bit high. Because in most of the paddy area, what happens, when the crop stand at vegetative phases, there might be a little bit variation in centimeters. But when we are going for the horticulture crops, some tall crops, there is a variation, particularly if you take areca, there is a variation in meters also. During that time, you can take factor as a flight height or the altitude as one of the factor for consideration. Okay, that is the one steps where we can take. That's why in paddy we have taken 1.5. Okay, for the different spray schedules, these are all the special nozzles we have used. We brought from the Delhi actually. So it is not available particularly in Karnataka. So there is a separate drone spare equipments available in Delhi only. So these are, yesterday I think I was shown. It's there? No, no problem. So it's a flat pan, especially we used for the herbicidal trials, because the spray, when we are spraying, it is in the V shape. It will be spreading like this. Okay, overlapping of those molecules is most important. In the insecticide and fungicide spray, we have used a flood jet nozzle. The spray is it in the circle dispersal will be there because of the crop mostly. Many of the insects and pathogens, when the vegetative growth starts after 30 days, the incidence will be very high. During that time, it has to cover the entire crop area. Here the target is soil. Here the target is plant. In herbicide, target is soil first. Then early post-emergent, it is only 10 to 12 days after the emergence of the weeds. Okay. Then with respect to the nutrient, where we want drift will not be there. This is anti-drift nozzle, that is hollow cone. Directly it will, like shower, it will spray. Okay. So all these nozzles we have considered to use these experimental studies. We have taken these are all the standard flying drone parameters. What we have taken, see, whenever we are doing the experiment, we have to disclose all those things, which model you are using and all that. That is the most important. Drone model we are using is AgriBoat, that is IoTech Navigation. It is a battery operated. We have fuel operated also, but that is not performing good right now. Nozzle type for flat type herbicide, you can also flat type or hollow cone you can use. Flying height, okay, 1.5 meter above the ground level if taking. Generally we should take above the crop canopy. You can mention, but from the crop canopy we are taken 1.5 meter. From the ground, we can consider 2. So it is in general 1.5 meter we can stand it. Because for the rice crop, anyway it is uniformity is there. Let us not go for the altitude as one of the factor. Okay. Effective spray width 3 meter. We have fixed it because all that can be Those program, Arsit, those programs, we can, I will, in the afternoon, we'll show the, when we are doing the planning missions, we can write the cats, or we can write the programs there. Because, how, sir, how we have fixed this one? So before flying, those parameters will be entered in the ground control station or the remote control. I want to discharge 10 liters per acre. So the swath width should be 3 meter. It is having, okay, 3, 4, 5, 6 meters. Then similarly water 10 liter, 15 liter, 20 liters. How much you want, you have to fix. Then your pressure, how much? 2, 3, 4, 5, 6 bar pressure, that is kg per centimeter square, you can fix. Then similarly, speed also. You want 3 meter, 4 meter, 5 meter. Because when I presented the drone rules, they have given for agriculture spray, it is from 3 meter to 8 meters can be considered for spray schedules. Okay, so that so based on the drift, droplet sizes and the distributions. If you go a little bit higher, considering the wind speed, we have to consider the wind speed. I think you can see when you are going for 3 meter per second, before flying, we have to see the ground stations. We have calculated that one during that season. Okay, what is the wind speed? If it is wind speed is more than 10 miles per hour, if it is more than 15 miles per hour, if it is more than 20 meters per miles per hour means you have to reduce the altitude. So those parameters to be analyzed before fixing of this. Yes, height means above the crop canopy at, so I will show you. This is the height, no? This is 1.5 meter above the ground. From the nozzle, this is the crop. From here, we have taken 1.5 meter. What is the criteria? Huh? Yes, flight altitude, flying altitude. Flying height or flying altitude. ಬೇರೆ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಮಾಡಕ್ಕೆ ಇಟ್ಸ್ ವೆರಿ ಸಿಂಪಲ್ ಸೊ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ದ no, not filler trial is not required. You will be getting the weather parameter data over the 30 years. We'll be knowing how much of per day. This was the morning wind speed and the evening wind speed. Okay, when the wind speed is too high, okay, you can reduce the down. If it is wind speed is too less means you can increase the height. If you are increasing the height means the dispersal will be very good. Considering the local parameters what we have, weather parameter is available, based on that flight height has been planned. That's all. That is the one criteria you should consider. So in randomly you can fix it. In general, what the agriculture drone rule says means you can take maximum height of 3 meters. That's all. From the not ground level, from the above the crop canopy. Not from the ground. Above the crop canopy, 3 meter is the maximum. Even you can, as a research studies, you can do for 4 meter, 5 meter. That's a different issues. Maximum it will be 3 because of the, they have already calculated the drift and everything. So that is the better. Otherwise, if it goes 4 meter, above the 4 meter, 5 meter means it acts as the principle of aerodynamics. That's what aerodynamics, what principle says, tomorrow they will tell. If you go a little bit height means what there are mainly thrust, pressure, how it will be creating, how much it will be pushing, tomorrow they will be presenting. So here we are considering only the technical part. So what happens if the flying drone, if it is 4 meter means how much of thrust it is pushing? That they will tell. Yeah. Yes. During the spray time. Yeah. No, you should not always calculate the ground because I will tell you why. This ground is, okay, this is little bit 1 feet or 2 feet, I think, huh? 1 feet, it was little bit high. So if you're taking the ground height means that is not good. Always we should take the crop height, above the crop canopy. Experiment plans, if you are planning means it should be above the crop canopy spray, not the ground. It will calculate only above the crop canopy. There is an option is there, above the crop canopy how much. I will tell you. For example, here, if the above the crop. Here the crop growth is good. Let us take here 15 centimeter plant height. Here the plant height is 10 centimeter. What happens? When we are fixing, so ಕೆಳಗಡೆಗೆ ಒಂದು ಸೆನ್ಸಾರ್ ಇದೆ, ರೆಡಾರ್ ಸೆನ್ಸಾರ್. Okay, what it will do, automatically it will reduce its height and it will spray. If the crop height is too high, automatically it will take its height, then it will spray. So that's why uniformity spray will be there. Okay, it will take it to the automatically it will calculate it. For that purpose, we should fix all the parameters whatever we require. No, only one. Only canopy, above crop canopy. Okay, now we understood? Fine. Because why we have to give the crop is most important. That is a criteria where the distribution, or maybe it may be herbicide, or it may be the fungicide, or it may be insecticide. Variabilities, heterogeneity, and the fertility status plays an important role. Okay. The first experiment with respect to the design RCBD, you can take any design, but many of the what now field experiment we are doing with the RCBD. Even if you are taking 2 factors, it will end up with the RCBD. Factorial design can be done with the 2 factors, 3 factors, many factors you can take. If you can go for the best designs for this drone experiment is one is RCBD, another one is split plot designs. Because in split plot you will be getting main and sub, that's all. In RCBD, again in simple RCBD, we have taken simple RCBD. If you want factors to be evaluated, factor 1 height, factor 2 water volume, factor 3 speed, factor 4 what you want to evaluate. You want herbicide or fungicide or insecticide or mineral nutrition. Got it? So you can take this many factors, but there is a problem. It's not like a lab experiment. I'll tell how the design should be done. Got it? Can anyone notice what is the gross plot size here? 100 meter square. In general, field experiment, if you are conducting means 20 meter square is the ideal plot size. Got it? So what is the size is increased here? 5 times. So conducting the drone field experiment means it's a bit tough. Means minimum plot size area will be required if you are based on your treatments. If you want to evaluate 1 factor, 2 factor, 3 factor, 4 factor, means entire factorial combination will come and end up with the 15-16 treatments. Multiply by 100 meter square for 1 replication. Multiply by 3. So it will cross more than 1 acre. What the statistics tells? If you take more plot sizes, there will be error more. So experimental error will be very high. So that is the main problem. That is why we are taking the 100 meter square, and how these designs and all those things I will tell. So ultimately we'll get some good number of plots. So that what happens, usually we do the manual flight during the experiment. We will not do the planning motions. Okay, every time you have to fix the plan, every time all your points to be coordinated and we have to fix. So during that time what happens, we'll fix the parameters, then we'll go for the manual flying. Only flying will be manual. During that time what happens, so these are, during that time what happens, 10 meter means 3 meter per second. Okay, 3 seconds will be reaching. Got it? So during 3 seconds, when you are taking the first loop, that means it is flying, you will be taking second left loop, then first right left loop. What yesterday Sunil was showing, planned mission mode, planned spraying. During that time, the border may be higher dosage or little bit dosage, because when it takes the loop means automatically again it will be same. So that's why the gross plot sizes will be, we should keep the experimental plots should be very bigger. So you can get 25 to 30 meter squares will be just like your normal experimental grass plot experiments. Okay, so we'll get number of samples. You can use many destructive samples for whatever the analysis you want. Okay, these are all the treatments you have taken. So yesterday what sir was did, so yes, sir presented the case study with related to the cotton and as well as which was the sponsored trial. But here we have taken the standard. This is the water volume. This is the recommended practices for our zone. This is recommended practices for North Karnataka, recommended practices for herbicide management. This is the zone. Here with the knapsack sprayer, the water volume is 300 liter per hectare. This is 1x, that is 3 ml per liter under normal with the knapsack sprayer. With this, the molecule has been based on the logarithmic scale, we have taken less, will it works or not. That is the one. Along with this, you can see the water volume you have taken 37.5. Okay, when we have done 10 liter, it was not working. Not working means if it is complete mission planning means during that time and based on the pilot sizes and based on the crop canopy, based on the height, so everything, bit we have increased the water volume 2.5 liter, that's all. Instead of 10, we have taken 12, 12.5, that's all. Okay, then same 0.5x with the 50 liters of water. Here we are evaluating only two factors. One 0.5x, another one, that means one is the molecule logarithmic, another one is water volume. We want to standardize only these two. Height is almost, height won't be too much variations because, so based on that we have 0.5, 0.75, 0.75, 1x, 1.5x, 2x, that's all we have taken. Within these treatments, we got a very good result in 2x. It is almost on par with your knapsack sprayers with respect to the weed density, weed biomass index, okay, weed control efficiency, okay, yield, and the droplet dispersion and as well as the particle sizes, everything was good in 2x. No need to go for 4x because when sir was presenting, it was almost, they have taken recommended practice, they have, almost with, they came to 25% reduction and 50% reduction molecules. Okay. One is based on your crop canopy, planting size, the crop canopy, okay, if the, to avoid the wastage in the planting areas, the planting size, what we'll be considering, the droplet size should be utilized very high. One thing, if you're using 10 liters of water in general, what sir was also telling, they have arrived at 60 liters. When the vegetative growth is too high, they have went up to 100 liters. So that is what we have taken. Based on the growth of the crop, that can be calculated. When we are done with the filler trial, I forgotten to put those slides. Before spraying, we have calibrated. Okay, what we did, per second, how much of discharge was there? Okay, I think for 53 seconds, how much we got? Pre-emergent and early post-emergent. We have taken both. Pendimethalin as a pre-emergent, 0 to 3 days, followed by bispirobacter sodium as a early post-emergent. ವೇರಿಯೇಷನ್ ಆಗಲ್ಲ, ಅದೇ ಓನ್ಲಿ 15 ಡೇಸ್ ಅಲ್ಲ ಸರ್, 15 ಡೇಸ್ ವರೆಗೆ ಇರುತ್ತೆ. ಅದಕ್ಕೆ ವಾಟರ್ ವ್ಯಾಲ್ಯೂಮ್ ನಾವು ತುಂಬ ಜಾಸ್ತಿ ಮಾಡಲಿಲ್ಲ, 2.5 ಮತ್ತು 50 ಲೀಟ್ರದ್ದು ಮಾಡ್ಕೊಂಡಿದ್ದು. 50 ಲೀಟ್ರ್ ಯಾಕಂದರೆ ಆ 50 ಲೀಟ್ರ್ ನಮಗೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಸರ್, ವೀಡ್ ಎಕ್ಸ್ಪ್ರೆಸ್ಸೇ ಆಗಲ್ಲ. ಇಫ್ ಯು ವಾಂಟ್ ಟು ಗೋ ಫಾರ್ 25 ಡೇಸ್ ಆಫ್ಟರ್ ಸ್ಪ್ರೇಯಿಂಗ್ ಶೆಡ್ಯೂಲ್, ದಿಸ್ ಅರ್ಲಿ ಪೋಸ್ಟ್ ಎಮರ್ಜೆಂಟ್ ಪೀರಿಯಡ್ ಏನಂದರೆ ಫ್ರಮ್ 12 ಡೇಸ್ ಟು 18 ಡೇಸ್ ವರೆಗೆ ಇರುತ್ತೆ. ಸಮ್ಟೈಮ್ಸ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಇಫ್ ಎವ್ರಿಥಿಂಗ್ ಈಸ್ ಗುಡ್, ದಿಸ್ ಕ್ರಾಪ್ ಹೈಟ್ ವಿಲ್ ಬಿಕಮ್ ಮೋರ್. ಆ ಟೈಮಲ್ಲಿ ನಾವು ಇನ್ಸೆಕ್ಟಿಸೈಡ್ ಏನಾದ್ರು ಮಿಕ್ಸ್ ಮಾಡಬೇಕಾದ್ರೆ, ಆ ಟೈಮಲ್ಲಿ ಇನ್ಸೆಕ್ಟಿಸೈಡ್ ಸ್ಪ್ರೇ ತೊಗೋಬೇಕಾದ್ರೆ ಸೇಮ್ ವಾಟರ್ ವ್ಯಾಲ್ಯೂಮ್ ವಿಲ್ ವರ್ಕ್ ಆರ್ ನಾಟ್. ದ ಸೇಮ್ ವ್ಯಾಲ್ಯೂಮ್ ವಿ ಹವ್ ಕಂಟಿನ್ಯೂಡ್ ಫಾರ್ ಇನ್ಸೆಕ್ಟಿಸೈಡ್, ಫಂಜಿಸೈಡ್ ಅಂಡ್ ಮಿಲ್ಟನ್ ನ್ಯೂಟ್ರಿಷನ್. ಓಕೆ, ಸೊ ಅಲ್ಲಿ ಮತ್ತೆ ನಾವು ವಾಟರ್ ವ್ಯಾಲ್ಯೂಮ್ ವೇರಿ ಮಾಡೋಕೆ ಹೋದರೆ ನಮಗೆ ಎಂಟೈರ್ ಪ್ಯಾಕೇಜ್ನ ಕೊಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. SOP ಸೇಮ್, ದಟ್ ಈಸ್ ವಾಟ್. ಯಾವುದು? ಹಾಂ, ದಟ್ ಈಸ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಡನ್ ಗುಡ್. 6 ml in how much liter? 20 liters. That is 120 liters. What is the volume? 3 ml multiplied by 3, 900 ml. How much of pesticide load has been reduced? Almost 60%. 6 into 5, 300 ml. 3 into 3, 900 ml. 600 ml is of molecule is reduced there. That I will present. ಯಾಕೆ? ನೋ 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 ದೆರ್ ಇಸ್ ಎ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಡಿಸ್ಪರ್ಸಲ್, ಅದಕ್ಕೆ ನಾನು ತೋರಿಸ್ತೀನಿ. ಡಿಸ್ಪರ್ಸಲ್ ಮೇಲೆ ವಿ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದೋಸ್. ವಿ ಹ್ಯಾವ್ ಡನ್ ಆಲ್ ದ ಫಿಲ್ಲರ್ ಟ್ರಯಲ್ಸ್, discharge rate, per square meter, what is the droplet sizes, everything we have calculated. If less water means what? If it is performing good, then it is good.
Even if we are trying to frame a trial, before framing the trial, we can just take a water spray.
We have done it. We have done it. So that's what I forgotten to put those photos. What we have done, we have marked a blank 10 by 10. We have flied, okay, with respect to the 10 liters, 12.5 liters and 15 liters. Okay, you have calculated the total droplet distribution. So in that cases, in 10 liters, it was very less. So that's why we have taken 12 liters and as well as 15 liters. So all those filler trials has been done before. Water. We have to do that one. We have to calculate. For example, if you want to go for spray in the mango, then the water volume will vary. Before that, you have to calculate how much of canopy is there. There it should be per tree basis, not per acre basis. We have to fly first. We have to see. Then you have to fix the treatments. We have did it everything. No. We have done everything. That's what I told now. In 52, I forgot. 52 seconds, we are receiving 753 ml for 52 seconds discharge in one nozzle. Okay, these are all the calendar of operations we did. Okay, now comes to the designing of field experiments.
ಒಂದ್ಸರಿ ಕೆನಪಿ ಇದೆಲ್ಲ ಸ್ಟ್ಯಾಂಡರ್ಡೈಸ್ ಆದ್ಮೇಲೆ ಬೇರೆ ಪ್ಲಾಟ್ ಹೋದಾಗ ಅದನ್ನೇ ಫಾಲೋ ಮಾಡ್ತಾರೆ ಸರ್. ಅಂದ್ರೆ ಕಮರ್ಷಿಯಲಿ ಅವ್ರು ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂದಾಗ
ಮಾಡ್ಬೋದು.
ಈಗ ಮ್ಯಾಂಗೋ ಒಂದು 10 ವರ್ಷಕ್ಕೆ ಒಂದು 5 ಲೀಟರ್ ಬೇಕಂತ ಹೇಳಿದ್ರೆ ನೆಕ್ಸ್ಟ್
Yes. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಪ್ರೋಟೋಕಾಲ್. ದಟ್ ಈಸ್ ಫಾರ್ ದಿ ರೀಜನ್ ವೇಸ್ಟ್. ಈಗ ಕೆಲವೊಂದು ಈಗ 5 ವರ್ಷದ ನೀವು ಪ್ರೂನ್ ಮಾಡಿದ್ರೆ ಯುವರ್ ವಾಟರ್ ವ್ಯಾಲ್ಯೂಮ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ ವಿಲ್ ಬಿ ಲೆಸ್. ಇಫ್ ಯು ಆರ್ ನಾಟ್ ಪ್ರೂನ್ಡ್ ಮೀನ್ಸ್ ಇಟ್ ರಿಕ್ವೈರ್ಸ್ ಮೋರ್ ಅಮೌಂಟ್ ಆಫ್ ವಾಟರ್.
ಅಥವಾ ಅಡಿಕೆಗಾದ್ರೆ ಸ್ಟ್ಯಾಂಡರ್ಡೈಸೇಷನ್ ಇದೆ 5 ವರ್ಷಕ್ಕೆ ಎಷ್ಟು,
5 ವರ್ಷಕ್ಕೆ ಎಷ್ಟು, 10 ವರ್ಷಕ್ಕೆ ಎಷ್ಟು.
ಒಂದು ತೋಟದಲ್ಲಿ ಸ್ಟ್ಯಾಂಡರ್ಡೈಸ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನೆಕ್ಸ್ಟ್
ಹೌದೌದು, ಯಾಕಂದ್ರೆ ಅದು 8 feet ಇದೆ. ಸೊ ದಟ್ ವಿಲ್ ಬಿ ಅಗೇನ್ ಆಟೋಮೋಷನ್. ಸೊ ಇಲ್ಲಾದ್ರೂ ಅಷ್ಟೇ, ವೆನ್ ವಿ ಆರ್ ಟೇಕನ್ ಅಪ್ ದ ಸ್ಪ್ರೇ, ವೆನ್ ಬಫರ್ ಝೋನ್ ಇರುತ್ತಲ್ಲ, ಬಫರ್ ಝೋನಲ್ಲಿ ಫ್ಲೈ ಆಗೋದಿಲ್ಲ ಅದು. ಇಟ್ ವಿಲ್ ಸೆನ್ಸ್. ನಾವು ಒಂದ್ಸಲ ಆಟೋಮೆಟಿಕ್ ಕೊಟ್ಟ ತಕ್ಷಣ ಇಟ್ ವಿಲ್ ಫ್ಲೈ. ಕ್ರಾಪ್ ಈಸ್ ದೇರ್, ಇಟ್ ವಿಲ್ ಫ್ಲೈ. ಇನ್ ಬಫರ್ ಝೋರಿಯಾ ಬಿಕಾಸ್ ಯಾಕಂದ್ರೆ ಐ ವಿಲ್ ಟೆಲ್ ಯು ವೈ. ಸ್ಟೆಬಿಲಿಟಿ, ಸಮ್ ಶಿವಕುಮಾರ್ ಸರ್ ವಾಸ್ ಟೆಲ್ಲಿಂಗ್, ಸ್ಟೆಬಿಲಿಟಿ ಆಫ್ ದಿ ಡ್ರೋನ್ ಈಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಬಿಕಾಸ್ ವೆನ್ ಯು ಆರ್ ಆಪರೇಟಿಂಗ್, ಓಕೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇನ್ ದಿ RC ಗ್ರೌಂಡ್ ಕಂಟ್ರೋಲ್ ಸ್ಟೇಷನ್ನಲ್ಲಿ ವೆನ್ ಯು ಆರ್ ಆಪರೇಟಿಂಗ್, you will be giving pitch forward. Pitch forward means drone should go forward. Automatically you want to take loop. Okay, then you will be giving left. Okay, command roll left or roll right will be giving. Pitch forward with roll right if you will give means if the stability of the drone is not good means it will vibrate. It will give jerk. Sometimes it may fall also. That's why what is the in the mission mode or in the automation mode, what it has been given, flying time, if you're on the dispersal of the molecule is done means only it will be sense the crop. What we will do, 10 meters, we'll take up the loop up to 15 meters. It will fly above with another treatment, but it will not spray. Then we can take the slow break, then you can take treatment again. ಆಫ್ ಮಾಡ್ತೀವಿ ನಾವು, ಇಲ್ಲೊಂದು ಬಟನ್ ಇರುತ್ತೆ. ಒನ್ಸ್ ಇಟ್ ವಿಲ್ ಬಿ, ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ ಕ್ರಾಪ್ ಇದೆ ಸರ್, ಇದು ಬಫರ್ ಏರಿಯಾ ಬಿಡ್ತೀವಿ. ಬಫರ್ ಏರಿಯಾ ಆದ ತಕ್ಷಣ ಆಟೋಮೆಟಿಕ್ ಸ್ಟಾಪ್ ಆಗುತ್ತೆ, ಅದು ಕ್ರಾಪ್ ಇರಲ್ಲ, ಅವಾಗ ಆಫ್ ಮಾಡ್ಬೋದು ಸರಿನಾ. ಮತ್ತೆ ಮುಂದಕ್ಕೆ ಹೋದಾಗ ಸ್ಪ್ರೇ ಆಗುತ್ತೆ. ದಟ್ಸ್ ವೈ ವಿಲ್ ಬಿ ಕೀಪಿಂಗ್ ದ ಬಫರ್ ಝೋನ್. ಐ ವಿಲ್ ಡೂ, ದಟ್ಸ್ ವಾಟ್ ಐ ವಿಲ್ ಟೆಲ್ಲಿಂಗ್. ದಿಸ್ ಈಸ್ ದ ಡಿಸೈನ್ ದಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್. ಓಕೆ, ಇನ್ ದ ಫಸ್ಟ್ ಒನ್ ವಿ ಹ್ಯಾವ್ ಡನ್ ವಿತ್ ದ ಕಂಪ್ಲೀಟ್ಲಿ ರ್ಯಾಂಡಮೈಸ್ಡ್. ಸೊ ವಾಟ್ ಆರ್ ದ ಡಿಸೈನ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಪ್ಲಾನ್ಡ್, ಐ ವಿಲ್ ಟೆಲ್. ಇನ್ ದ ಕಂಪ್ಲೀಟ್ಲಿ ರ್ಯಾಂಡಮೈಸ್ಡ್, the variability among the experimental units, it ensures that each treatment is randomly assigned to an experimental unit within each block. So that this is good because of the plot, entire plot is heterogeneity is there. So all the treatments are randomized. Okay, this is the layout. Okay, for any field experiments, if you are taking for pulse, commercial crops or the cereals, okay, whatever you are taking, first buffer zone between the replication minimum 3 meters. Should be 3 meters. We cannot take less than that. I will tell you why. Many of the drones, they don't have automation. Manual will be there. During that time, what happens? At least in 3 meter, at least for 1 second, you can get control your drones. That's why we'll be keeping a minimum. What is the speed? 3 meter per second. That's why we'll be keeping the buffer area 3 meters between the application. Then between the treatments, you can keep 2 meters or 3 meters. Okay, you can keep between the treatments 2 meters or 3 meters. So we have taken 1.5 meters. That is not an issue because anyway gross plot size area will be remaining. That's not an issue. This is how your layout should be. Between the replication 3, between the treatment, if you are first time doing the experiments and all those things, 1.5 meter and above, how much you want, you can take that one. So sir, what yesterday what sir has did, he has planned the other crops to new the buffer area to wastage of. Otherwise, what happens during the experimental plot, entire area will be acquired by these weeds. That is the major problem with field experiments.
Sir, total area required for training this trial?
1 acre. 0.98 acres. Because it is based on the treatment. If the less treatment means even in half an acre you can conduct. That I will tell. Even randomize ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೂ ಕೂಡ ಸರ ಟ್ರೀಟ್ಮೆಂಟ್ ಇರುತ್ತಲ್ಲ ಅವಾಗ ನಿಮಗೆ ಬೇಕಾಗುತ್ತೆ. Then we'll be keeping the block constant. Only within the block treatments you are not randomizing. That is we call it as a partial randomization and incomplete randomization. That I will show in the next. ಕಷ್ಟ, ಅದಕ್ಕೆ ಡ್ರೋನ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟೇ ಕಷ್ಟ ಮೇಡಮ್. ಯು ಹ್ಯಾವ್ ಟು ಟ್ರೈ, ಅದರ್ವೈಸ್ ಯು ವಾಂಟ್ ಗೆಟ್ ದ ರಿಸಲ್ಟ್. ಹಾಂ, ಕರೆಕ್ಟ್ ಮಾಡ್ಬೋದು. ನೋ 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 ನಿಮಗೆ ಇದು ಸಿಗಲ್ಲ ಅವಾಗ, ವಾಟ್ ಯು ಕಾಲ್ಡ್ ಡಿಗ್ರೀಸ್ ಆಫ್ ಫ್ರೀಡಮ್ ಸಿಗಲ್ಲ ನಿಮಗೆ. ಹಾಂ, ದೆನ್ ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡೂ, ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಈಚ್ ಫಾರ್ಮರ್ ಆ್ಯಸ್ ಎ 1 replication. 20 farmers is 20 replication. ಮಾಡ್ಬೋದು, ಅದು ಹೆಟ್ರೋಜೆನಿಟಿ ಇರುತ್ತೆ ಅವಾಗ. ಸೊ ಒಬ್ಬ ಫಾರ್ಮರ್ ಈಸ್ ನಾಟ್ ಎ ಟ್ರೀಟ್ಮೆಂಟ್, ಈಸ್ ಎ ರ್ಯಾಂಡಮೈಸ್ಡ್ ಮ್ಯಾನ್. ದಟ್ ವಿಲ್ ಬಿಕಮ್ ಎ ರೆಪ್ಲಿಕೇಶನ್, ನಾಟ್ ರ್ಯಾಂಡಮ್. ದಟ್ ಈಸ್ ಎ ರೆಪ್ಲಿಕೇಶನ್ ಅವಾಗ. ಪರ್ಟಿಕ್ಯುಲರ್ ಇನ್ ಹಾರ್ಟಿಕಲ್ಚರ್ ಕ್ರಾಪ್ಸ್ ಹಾಗೆ ಆಗೋದು. ಸೊ ವಾಟ್ ದೇ ವಿಲ್ ಡೂ, ದೇ ವಿಲ್ ಟ್ರೀಟ್ ಈಚ್ ಟ್ರೀ ಆಸ್ ಎ replication in some cases. Okay, this is with respect to the complete randomization. Sir. Narappa, I have given for complete randomization. You will see here. What is here? Restricted randomization. I will show one by one how we can plan your experiments. This is one set of designing. That I will tell. This is one set of designing if we are completely randomizing. Got it? Then second set of design where you are partially randomizing, where exactly you want to concentrate. That I will show. This is only set of treatments completely randomized. Completely randomized. T1 is here, T1 is here, T1 is here. T2 is here, T2 is here, T2 is here. That is called complete randomization. Got it? Yada? Illappa. One day treatment on the value. T1 means 37, 37, 37. Only rep. Very agutte irli. Yes. 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 Treatment fix ಮಾಡ್ತೀವಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒನ್ ಟ್ರೀಟ್ಮೆಂಟ್ ಆಲ್ ದ 3 ರೆಪ್ಲಿಕೇಶನ್ಸ್ನ ನಿಮ್ಗೆ ತೋರಿಸ್ತೀನಿ. ನಾವು ಹೋಗ್ಬೇಕಾದ್ರೆ ಒಂದ್ಸಲ ಫುಲ್ ಪ್ಯಾಕ್, ನಾವು ಲಗೇಜು ಡಬ್ಬಿ, ನಮ್ದೊಂಥರ ಶಾರುಖ್ ಖಾನ್ ಕಾರ್ ಇತ್ತಲ್ಲ, ಅದು ಯಾವುದೊಂದು ಮೂವಿ, ಐ ಫರ್ಗೆಟನ್ ಟು ಟೆಲ್ ದಟ್ ಒನ್. ಶಾರುಖ್ ಖಾನ್ ಒಂದು ಮೂವಿ ಇತ್ತಲ್ಲ ಸರ್, ಅವನ್ನೆಲ್ಲ ಅದ್ರಾಗೆ ಇರುತ್ತಲ್ಲ, ಹಂಗಾಗ್ಬಿಟ್ಟಿದ್ದು. ನಾವು ಹೊಂಟ್ರೆ ಡ್ರೋನು, ಅದರೊಳಗೆ ಬಾಕ್ಸು ಎಲ್ಲ ಅಲ್ಲೂ ಸ್ವದೇಶ್. ಸೊ ಇನ್ ದಟ್ ವೆಹಿಕಲ್ ವಿ ಹ್ಯಾವ್ ಎವ್ರಿಥಿಂಗ್ ಇನ್ಕ್ಲೂಡಿಂಗ್ ಸ್ಮಾಲ್ ರಿಪೇರಿಂಗ್, ಎಲ್ಲದು ಅದರಲ್ಲೇ ಇರ್ಬೇಕು ನಮಗೆ. ಹಾಗಾಗಿ ಡ್ರೋನ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡೋದು ಪ್ರಾಬ್ಲಮ್ ಈಸ್ ಮೊಬಿಲಿಟಿ ಒನ್ ಥಿಂಗ್, ಬಿಕಾಸ್ ನಾಟ್ ಲೈಕ್ ಸೊ ಕೆಮಿಕಲ್ ತಗೊಂಡಾಗ ಅಲ್ಲಿ ಯಾರಿಗಾರು ನೆಪ್ಸಾಕ್ ಸ್ಪ್ರೇಯರ್. ಇಲ್ಲಿ ನಾವು ಡೋಸೇಜ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡೋಕ್ಕೆ ಪ್ರತಿ ಸಲ ಮಾಡಲಿಕ್ಕಲ್ಲ. ವಿ ಹ್ಯಾವ್ ದ 5 ಲೀಟರ್ಸ್ ಆಫ್ ಕ್ಯಾನ್, ಒಂದು 14-15 ಕ್ಯಾನ್ ಇಟ್ಕೊಂಡಿದ್ದೀವಿ. ಫಸ್ಟಿಗೆ ಅದು ಸೊಲ್ಯೂಷನ್ ಸ್ಟ್ಯಾಂಡರ್ಡೈಸ್ ಮಾಡಿ ಇಟ್ಕೊತೀವಿ. ಎಲ್ಲ ಕ್ಯಾನಿಗೆ ತುಂಬಿದ ಆದಮೇಲೆ ರೆಪ್ಲಿಕೇಶನ್ಗೆ ಎಷ್ಟೆಷ್ಟು ಬೇಕು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ತುಂಬಿ ಆಮೇಲೆ ವಿಲ್ ಗೋ ಫಾರ್ ಸ್ಪ್ರೇಯಿಂಗ್ R1, R2, R3. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಯುವರ್ ಎಂಡ್ಯೂರೆನ್ಸ್ ಬ್ಯಾಟ್ರಿ ಯು ರಿಕ್ವೈರ್ ಮೋರ್ ನಂಬರ್ಸ್. ನಮಗೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಎಲ್ಲ ಗೊತ್ತಾಗಲಿಲ್ಲ, ಸುಮ್ಮನೆ 2 ಡ್ರೋನ್ ಹೊಡೆದು ಆಮೇಲೆ ಮತ್ತೆ 2 ತಾಸು ಚಾರ್ಜಿಗೆ ಇಡೋದು, ಮತ್ತೆ ಕೂತ್ಕೊಂಡು ರಾತ್ರಿ 9 ಗಂಟೆ ಆದ್ರೂ ಮುಗಿತಿರಲಿಲ್ಲ ನಮ್ಮ ಫ್ಲೈಯಿಂಗ್. Yes, that's what. If you want to take the experiment in particularly drone, minimum 1 pilot, 2 co-pilots, 2 assistants you require. And when is your flying time? As for the drones, when is your flying time? 6 to 10. You have to complete the entire experiment area. Okay, no? 6ಗೆ ಮಾಡಬೇಕಂದ್ರೆ ರಾತ್ರಿ ಕೂತು ನಾವೆಲ್ಲ ಡಬ್ಬಿ ಕೆಮಿಕಲ್ ತುಂಬಿ, ರಾತ್ರಿ ಹೋಗಿ ಹಾಲ್ಟ್ ಆಗಿ ಕೆಮಿಕಲ್ ತುಂಬಿ ಆಮೇಲೆ ಬೆಳಗ್ಗೆ ಅಷ್ಟೊತ್ತಿಗೆ 6 ಗಂಟೆಗೆ ಪ್ಲಾಟಿಗೆ ರೀಚ್ ಆಗ್ತಿದೆ. ನೀವು 6 ಗಂಟೆಗೆ ಹೋಗಿ ಆ ಸೊಲ್ಯೂಷನ್ ರೆಡಿ ಮಾಡಿ ಮಾಡೋಷ್ಟೊತ್ತಿಗೆ ಇಟ್ ವಿಲ್ ಟೇಕ್ ಟೈಮ್. ಬ್ಯಾಟ್ರಿ ಸೆಟ್ಸ್, ಇಫ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಮಲ್ಟಿಪಲ್ ಬ್ಯಾಟ್ರಿ ಸೆಟ್ ಫಾರ್ 1 ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ 1 ಎಕರ್ ಇದ್ರು ವಿ ನೀಡ್ 3 ಬ್ಯಾಟ್ರಿ ಸೆಟ್ಸ್, ಬಿಕಾಸ್ ಟೇಕ್ ಆಫ್ ಇಟ್ ವಿಲ್ ಟೇಕ್ ಮೋರ್ ಎನರ್ಜಿ, ಫ್ಲೈ ಅಗೇನ್ ಲ್ಯಾಂಡಿಂಗ್, put the T2 treatment, take off. Up to 13 treatments you have to take off and land, take off and land. FLD ನೀವು ಲಾರ್ಜ್ ಏರಿಯಾ ಇರುತ್ತಲ್ಲ ಮೇಡಮ್, ಅಲ್ಲ ದಟ್ ಈಸ್ ಡೆಮಾನ್ಸ್ಟ್ರೇಷನ್ ಈಸ್ ಡಿಫ್ರೆಂಟ್. ಸಿ ಒನ್ಸ್ ಯು ವಿಲ್ ಬಿ ಸ್ಟ್ಯಾಂಡರ್ಡೈಸ್, ದೆನ್ ಓನ್ಲಿ ಯು ಕ್ಯಾನ್ ಗೋ ಟು ದಿ ಫಾರ್ಮರ್ಸ್ ಫೀಲ್ಡ್. Until and unless you won't develop the standard. So when you are going for the farmer's field, you should know the exact dosage. When you don't know the dosage for the farmer's field, why you are going? Okay. So this is what the complete randomization. If you come to the statistical design, okay, I am showing all the statistical designs with respect to the restricted randomization, complete randomization, and non-randomization. All the statistical ANOVA will be giving the same. It won't varies. Only for the experimental purpose, to reduce the error, we can do this type of experiments, designing of these experiments. Okay. Again, it is a restricted randomization. Can you see? I have changed the name. What Dr. Narappa was telling, T4, T4, T4. Okay. T3, T3, T3. T2, T2, T2. T1, T1, T1. These treatments are, okay, where what it tells, experimental units in a controlled manner to meet the predefined criteria. My criteria is flying height, droplet distribution, and the management. That's what. Okay, rather than being completely randomized. ನಮಗೆ ಎಷ್ಟು ಯಾವ ಟ್ರೀಟ್ಮೆಂಟ್ ಮೇಲೆ ನಾವು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡ್ತೀವಿ, so what we'll be doing here is in the predefined manner. Okay, here to reduce the error, what happens? So these treatments are fixed so that the flying can be continuously planned. Okay, but what about the other treatments? We are randomized. You can see what is this? T5 is here, T5 is here, T5 is here. Other treatments go for randomization. Yes. If you are taking, so that's what is the treatment you are planning means, that's what you can plan. So it goes with restricted randomization. For example, T1, T2, T3, only with spray. If it height it varies means, again you can change it. That's not an. These experiments can also be planned. This is called as restricted randomizations. Particularly in organic field experiments, they are doing like this. But there they are doing complete non-randomization techniques. Okay, this is another way of designing your experiments. Paddy. No, what is the recommended practice is there we have taken. Spacing is recommendation. Spacing that we are not evaluating. Ours main is only the drone based experiment. Spacing 30, 10, that's a different issues. Whatever the recommended practices is there, you can take. That's a different issues.
So again it is your in the restricted randomization, the same statistical design, it won't change. Okay. Again, randomized completely block design with non-replicated trials. In the non-replicated, you can see from T1 to T13, it is same. In the restricted randomization, we are randomized only the treatment which you are looking here. Those treatments are fixed and other treatments are randomized. With respect to here, all the treatments, it is like almost a LSD trial, Latin square design. That means your both replication, the treatments are equal. Okay? Huh? Allowed. It is purely what in Balasubramanian statistical designs. From there only I copied this one. The statistical designs can be experimented for drone experiment, for drone. Otherwise, if you are doing with this means only 2 set of batteries enough. When you are doing complete randomization, you need 4 set of batteries. Got it? That's all. See how the errors or whatever it may be, it is, so that can be planned. Okay? In the similar case, see, so for example, here I could have been taken in the experiments, I could have been taken 0.5x, that means dosage as a one factor. That is a main factor. Second factor is your water volume. Third factor is maybe your spraying time or whatever it may be. Even though if it is factorial, again when you are declaring, it will become a RCBD only. So in the similar way, split plot can be done. Again in split plot, main plot and subplot. Got it? So again, even though in non-randomized design, your ANOVA will be same. Just T1 minus 1, B minus 1. There won't be any changes within the sum of treatments or blocks or error or total what is there, it will be same. Okay? So through with the designs, good. What am that? See, people will tell, see, complete randomization is required. In that cases, you will not at all plan for the drone experiments. Then they will say, hey, it will not feasible because plot size is 100 meter square. You have to evaluate all the treatments. Okay, if that was the cases means people will say then it will go more than 1.5 acres. Then field errors will be very high, so it is very difficult to conduct. In that cases, they are given exceptional with respect to the what exactly you are targeting. That is what in the I have given A blocks are expected to be more similar to each other than the units rather than the blocks. So they Balasubramanian means many of the statistical in the design they have given the clear cut. So this type of, for example, if you want to evaluate the in particularly organic farming experiment or in a, so recently we have closed one project that is natural farming. So those are all they have done with this non-replicated only. Okay, fine. So this is what just I will show the activities related what we have done. This is, see, you can see this is 3 meter. This is 1.5 meter. We have considered the flying at 1.5 meter with respect to the paddy. Okay, before what are the free flight checks to be done before flying and all those things, everything will be showed. So we are comparing with the normal knapsack sprayer at the different stages. So I want to tell about this. See, yesterday sir was telling how the droplet sizes will be. For us, we have calculated the droplet sizes at 10 centimeter. You have staked the stick, then it is 10 centimeter and the 30 centimeter. Okay, that's the most important because generally your dispersal above the crop canopy when you are considering how much it is reaching the ground, you can see the number of droplets, sizes and the distribution is very less. Here, bit of high. So in herbicidal experiments, if it is not reaching early post-emergent, this is good. Even with this, it will varies based on the what sir was telling. No, when you started flying, immediately your wind speed will be more than 20 or 30 kilometers. That error also be one of the problem to get the less accuracy in your field experiments. Always when we are taking the thrust we should consider and also that is what usually from morning 6 to 10, the general wind speed in many of the regions will be less than 10 kilometer per hour. So that's why the DGC has fixed you should take the flying 6 to 10 with respect to the wind speed and also the temperature. Generally it will be around 25 to 26 degrees Celsius and in the evening hours. So for every treatment we are fixing 2 to 3 during flying. So if you will be taking one time, that is good enough. For all the treatments it is not required, only for 37.7 liters and 50 liters. Yes. Sir, sir? Yes, sir. So that is what we have evaluated. For example, sir, this is at 20 days. For just take example 15 to 20 days. ಆ ಪ್ರೆಷರಲ್ಲಿ ಇಲ್ಲಿ 2 to 3 ಲೀಫ್ ಸ್ಟೇಜ್ ಏನಿರುತ್ತಲ್ಲ ಸರ್, ರೀಚ್ ಆಗುತ್ತದು. ಇಟ್ ವಿಲ್ ರೀಚ್, ದಟ್ಸ್ ಪ್ರಾಬ್ಲಮ್ ಏನಿಲ್ಲ, ಇಟ್ ವಿಲ್ ರೀಚ್. ಸ್ಟ್ಯಾಂಡಿಂಗ್ ವಾಟರಲ್ಲಿ ಇರುತ್ತೆ, ಏನು ತೊಂದರೆ ಇಲ್ಲ. ನೋ ನೋ ನೋ, ಇಟ್ ವಿಲ್ ರೀಚ್ ಸರ್, ಇಟ್ ವಿಲ್ ರೀಚ್. ರೀಚ್ ಆಗುತ್ತೆ, ಅದು ಗ್ರೌಂಡ್ ಲೆವೆಲ್ ರೀಚ್ ಆಗುತ್ತೆ, ಅದು ಇಟ್ ವಿಲ್ ರೀಚ್. Okay, so you can see knapsack sprayer generally we are spraying at 60 centimeter height from the above the crop canopy. Here we have taken 1.5 meter above the crop canopy. Still you can see the distribution of the droplet sizes. One is size, density and the distribution. That is a different issue. We are considering only the height and the drops, that's all. Yes. Okay. With this again we will be calculating. That's what it will reach. See, you cannot see, only we are calculating how much 10 centimeter, only this much. When it is reaching means the crop canopy will be there, it will be absorbed there. That's not a problem. We will be not considering zero. Sensitive paper na zero get bitre ಕೆಳಗಡೆ ನೀರೇ. See, when you are keeping at the zero, so it is in the wet condition, automatically it will give error. Okay. Yes, it is only the sample paper. That's what I told. How much of droplets is varying at the different height stages. Yes, see 30 centimeter. What happens here? Wind's break will be there generally within the crop. When it there, wind flowing will be there above the crop canopy. Okay, sometime it is absorbed by the crop, sometime it is absorbed by the ground level. Okay, what are the observation? For example, we are doing the phytotoxicity observations. For example, no injury and the slighting. Then based on this, we'll giving. For example, why we are doing means when you are doing for the evaluation of the new molecules. So during that time, phytotoxicity is very, very important at the higher level, higher dosage. But even we have done in the filler trial, if you are doing at the 3x, 4x level, sir was telling, I think as for the sir's yesterday presentation, I think it is 6x. I think we have calculated it will comes around 6x. Even in 6x, phytotoxicity was not there. But when it is giving good result in 2x or 3x, no need to go for 6x. Okay, weed density, weed control, weed biomass and all those things. Similarly, we have done with the systemic and as well as contact insecticides applied through agriculture drone against a pest. Again in Bhavkere, so again the plot size is around 100 meters, 100 meters square. These are all the activities, spraying schedules, because many cases our spray may skip. Why? When the incidence is not noticed means that will become zero. So, but still we are considering the spray schedules, because sometimes if the farmers stage is also considered for the spray schedules, means that is the reason we have taken. Before this one, we are going for the pest load index. What is that? Ready? What we exactly were doing? Ready? So before spray seeding, what we will be doing? PDE. Pre-count. So we'll be pre-counting based on the pre-count. So even though injury or the incidence is not too much high, how much of minimum is also there, means we'll be considering that one. Pre-count, then we go for the spray. Whenever you are going for this one, okay, we have to consider the pre-count. In our case, what happens in the post-emergent only, we are considering the weed count in 1 meter square area. Similarly here, number of insects or maybe sucking pest or whatever XYZ is there, considering per meter square area will be calculated before 1 day before spraying. We have to take. That tells us, we can postpone. You can see the dates. That's why whenever I see, you can see the date. That's why we will not be mentioning the exact date. Maximum tillering stages, maximum booting stages. Okay, so that we have calculated not the exact date. Sometimes in early variety or the medium duration or long duration variety. That's why we are described at the stages. If it is today, if it is not no streams, let us wait for another 1 week. Then so usually farmers practices is also like that. No, when the unit notices, you can take up the spray. That's all. The same criteria has been used. Here again, we have used 3 stages only because in majority of the cases, what they have done with the pre trials or the counts. See, in paddy, usually at the 3 different stages, in our university jurisdiction, we are noticing the insects predominance. So that's why we considered at the early stages, vegetative stages. Another one is at maximum tillering stages. Another one is at milking stages. That's all. 3 stages we have to consider. Then again, the molecule is the same. So this experiment is formulated by Dr. Sharanappa and Dr. Krishna Reddy. Okay. ಈಗ ಗಂಧಿ ಬಗ್ ಬರುತ್ತೆ. If it is gandhi bug notice, means you have to go for spray. That comes only during milking stages. No. That's why we have taken general. See, maximum tillering. That's why systemic and contact. That's what you can see the title. Systemic and contact, both irrespective, broad spectrum. You can see the term broad spectrum. In all the experiments, we have taken the broad spectrum. ಹಂಗೂ ಮಾಡ್ಬೋದು. That also you can do it. We have taken broad spectrum only regions. Many of the farmers, they use the broad spectrums. In the market, the products are available also broad spectrum. Even in herbicide, insecticide or fungicides, they go for the broad spectrums. In very rare case, narrow spectrums, insecticide, this one they are using. Okay, so I want to show this one. See, before flying, we are keeping all the cans. We'll be evaluating. So this is morning at 5:30. So we are calculating all those one. We are putting the what is the quantum of water is required based on your treatment sizes. Okay, then will be kept ready so that in experiments those cans will be kept it. Because landing also in paddy field, I will show you. We have created on platform. I will show in the next slide. We have artificial drone pad we have created in the field. It is a mobile one, like just like helipad is there, no? We got a drone pad. So we'll be keeping from one place to another locations. Otherwise, for example, what happens now in the field condition, entire area is cropped area. So you have to land your drone. Where you will land? So even in standing crop also, when the crop height is good, means your propeller will be struck and it will get damaged. Okay. So everything should be very planned. Otherwise, the conducting experiment. See, these are all the errors which can be controlled by, managed or controlled by us. But field experiment, it is difficult. But this type of errors, we can reduce it. Okay, fine. So again, in the phytotoxicity, with respect to the yellowing, stunting, necrosis, epinostic crop recovery. So then after the observation, we got some good results. So observation recording in all the, so again in the pathology trials also at AHRS Varnaville. So again we are broad spectrum, we have taken both systemic and contact fungicides, applied at the 3 different stages. The purpose of taking the different stages is only thing, we have to give the complete set of package to the farmers. If you notice only insects during milking stages, means you can use this one. If we noticed only insect during tillering stages, you can use this package. That's all. Okay, these are all designing and layout. Again, we have done with the tricyclazole and carbon enzyme plus mancozeb again during our different stages, vegetative, tillering and panicle initiation stages. What they have declared during that time, usually pathogens will be noticed. So based on that, we have considered this trial. So okay, this is platform. It is a foldable one. Okay, so whenever you are flying means based on the height you can adjust it. Okay, 1 meter, 1.5 meters threaded one. So you can land anywhere. So usually we keep this platform where we have kept the buffer zone area. 3 meter is there, no? That will be very easy for. Flat area is required, one thing. And the second thing, it should see what happens, particularly panicle stages. You can see the drone height is hardly around 40 centimeters, sir. So crop height is during milking stage, panicle stage, it is 70 centimeter. If you are landing in the crop means propellers gone. That's all. You can see, madam, me only. So we are moving from one location to other location, one more location to other location. Okay. So again, this is phytotoxicity related. See, so whatever all the activities, other activities, boarding and everything, it will be helpful during buffering zone areas only. You can plant other crops also, that's not an issue. What generally we do means, for the first season we have kept, in the second season we started planting. What we did, we are removing only the border one line from this line. So then what we have suggested, those 2 support employees will be there, no, along with the co-pilots, will be standing at the end. So we'll be telling here it will stop. That's all. So rather than, otherwise, first season we did it. So in the first season, the weed management cost has become more there. In the buffer zone area, full weed growth we have noticed there. So even though what happens, everything you have to plan, no? You have to go there and you have to fix the diagonals there. That is the difficult plot. Everything. If it is big plot means, usually along with this, I am having. That's what you have to take the big plot size. That's why your net plot size can be lesser. In usually what happens in the general experiments, we will be doing 20 meters square. Here we are doing 100 meters square. Let us all 50 meters square go as a gross plot. Anyway will be getting the net plot. So that is good enough. ಕಷ್ಟ ಆಗುತ್ತೆ ಮೇಡಮ್, ಹಂಗೆ ಅನ್ಸುತ್ತೆ ಅಷ್ಟೇ. It is very problem, I will tell you. Small plot mapping, you have to map all, for example, if you are flying for T1, T2, T3 treatment, you have to go, you have to put all the coordinates, T1, again you have to put, ಅಷ್ಟೊತ್ತಿಗೆ 10 ಗಂಟೆಗೆ 12 ಗಂಟೆ, it will be around 12 o'clock. No, so that if your treatments is only 2 or 3, you can plan. So if your experimental treatments is that definitely, sir, what you said, that will become easy. But what happens, sometimes if you want to shift the location, then that will be difficult. Yes, it will store. We did that thing also. But every time again we have to reload the program, we have to reload the location, everything. So that's why anyway now if the pilot is perfect means manual is good if the experiment. Okay. With respect to the foliar nutrition, again, we are conducting at Brahmavara stations. We are comparing with the conventional and as well as agriculture drone sprayers. So with a knapsack sprayer which is 16 liter. So with respect to the soil sense. So because foliar nutrition generally we have to it has to be evaluated by the soil scientist only. Okay. So these are all the activities related to there. So you can see this is the complete set of plant. So this is the buffer zone. You can see treatment which has been loaded has been kept in all the locations. Okay. So the product what we have used is multi-nutrient which has been evaluated by the US Dharwad, US Raichur. Okay, instead of 19 all. So there is a crop specific. Now Dr. Adarsha Monday he will be presenting specialty products. Specialty product means I want to go for the crop requirement at 20 days means you can take the specialty products like paddy 20 days. That's all. What it contains? It contains all the nutrient requirement for that particular crops. In future, the customized fertilizers will be taking the role. So that means specialty products. That's why we started evaluating. So in future, there won't be direct spray like NPK, calcium, magnesium. So everything at different stage. Farmer will be coming. So my crop is at 50 stage. Give the nutrient. So he can take that. That is what customized, specialized nutrients. That's what we evaluated. This one. So again, treatments with respect to we have done initial soil samples. Based on the soil samples, how much you can able to fulfill through foliar spray schedules. Okay, RDF we have kept, then we have reduced 50, then we have reduced the 75. So then at the different stages, maximum tillering, grain filling stages, and before panicle initiations. So we have tried all the 3 stages for the evaluations. Okay, again observation we will be seeing the phytotoxicity levels. Okay, now we are left with the Kharif and Rabi season for one more year. So we have data, so we have not presented here. So once we'll getting the complete data set analyzed, we'll be publishing. Okay. Yeah. Yes. Water volume. If you want height means height. 3 height and speed. Speed, sir. Drone speed. Flying speed, not drone speed, flying speed. That's what. So first you can evaluate. Then if the molecules are different, for example, sir, if you are evaluating for the different molecule sizes, we cannot consider again the block sizes. Volume will vary, say, insecticide. Sir, when you are doing for statistical analysis, then that will become very difficult. You will not get the degrees of freedom. Doddu black made, your point is making one big block, so there you have to divide. The one replication made statistical problem. That's what. So that is possible in your GPB experiment, sir. Usually, as for the degrees of freedom, usually in the field experiments, replicated, we have to take minimum of, if it is more than 15 means you can take 2 replications. That is also possible. But so now people may ask too many questions. We are through with as for the present statistical designs only. Then as and when the SOP and others. Correct, sir, correct. You are absolute. But this we have to give it in a scientific report. When you are presenting in the scientific body means they will ask, you are not taken the randomization, you are not taken the replications, then that's the common questions. That's what see, those error we are avoiding. Even though it is risky, but we are trying. So that in the first Kharif season, we have done complete randomization. In the second one, we have did with the restricted randomization. Already, so continue now one day treatment pakka it ಮಾಡಿದ್ದೇವೆ ಅವಾಗ. That's what, see, from the we are keeping, now we are doing only restricted randomization. Huh? We are doing the same thing. In that we are taking only in 100 meter square, we are taking all. That way. Thank you. Any questions? No, because it is for the region-based SOPs. You can evaluate for your region-based studies. That is also important. So field size you can plan. Once you will be knowing, that will be different. Because when we started the experiment, no one was there to guide us. We went for only review papers. What all the reviews was telling. Some experiment, in many of the experiments, they have given minimum plot size 90 meter square. One acre. No, sir, 10 liters will come on. Now, point, sir, with, I will tell you, see, there should be dedicated, now, even I am doing only piloting, but all the accuracy, the dosage and everything has been taken care by, I cannot say he is my SRF, he is my, really is a good hand, technical hand with me. Because of him only I am doing everything. The person behind this one, because he is calculating if it is 10 liters for plot size, if it is 98 meter square means he has to calculate the 375 ml and everything. Dose accordingly it has to be go. That's what. It is, even though it is 2 seasons, we have taken the risk to done this. See, if it is 50 liters per hectare means, based on the 100 meter square, how much of water is required, how much of molecule is required. That's all. For that purpose, in general, we have taken 5 liters tank. 5 liters tank means for 3 replication, T1, 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 all the 3 replicated can be loaded in the one can. Yes. So, see once, see for example, definitely for another 2-3 years, we have to do rigorously. Once we'll be knowing for the different crops, we'll be publishing 2x with 1.5 meter of height, okay, with this much of dosage. If you want to conduct the experiment, you can take only 2x and 3x, 1.5 meter. Ah. 50. 3 levels, sir. 1 level. When the reviews was telling it was 10 liter was not at all enough. We have removed it. Problems. That's what. Yes. Yes. Height and everything. Pre-emergent, that's what. Pre-emergent, I think it is. You open the. ನಿಮಗೆ ವಾಟ್ಸಪ್ ಇದು ವೆಬ್ ವಾಟ್ಸಪ್ ವಾಟ್ಸಪ್ ವೆಬ್ ಇದೆಯಾ ಅದು ಮೇಲ್ ಚೆಕ್ ಮಾಡಿ ನಂದು ಮೇಲ್ ನೀನು ಮೇಲಿಗೆ ಫಾರ್ವರ್ಡ್ ಮಾಡ್ತೀನಿ ಮೇಲ್ ಓಪನ್ we are doing on the soybean and also the maize. I am taking less burden and putting all the burden to my PhD and as well as MSc students. They should take all those risks. Sir, that's what. See, some pulses studies, if it is been known, it will become a thumb rule, for example. That's what. In case of pulses, if based on the crop canopy, the crop height is in general plus or minus only 15 centimeters. So then you can fix the height. Once any review paper with respect to our condition, if the flying height is 1.5 meter above crop canopy means that is fixed. That's all. That's why I fixed 1.5 meter means all the review papers what they are telling, they have taken up to 4 meters. When we have seen the droplet size, distribution and the density, it was good at 1 to 2 meters. So we have reduced it. That is what. See, already there is lot of work has been done on rice. But now in many crops it has to be worked. Because rice being an international crops, the many of papers what I reviewed, they have done major work in Asian countries only. So last December I went to Asian Specific Weed Science Society. So majority of the works are related to the, so it was organized at Phuket. When I visited there, many of the rice relative work now they are advancing with this only, with the drone experiments. Particularly Japan, they are doing very excellent work, and the Thailand they are doing very excellent work, and Philippines, not even China. So the presenters, those who have presented at the different sessions, only Japan and as well as Thailand and the Philippines, they are doing good work on the rice. Because when I went for the review, in the maize crop, zero work with respect to the. So then I thought to have the different flying guides. I took the different flying guides there. Okay, I will show the experiment details. Even for soybean also, we have planned. One PhD students working on that, this one. Yeah. That is what we are developing the SOPs. That is the SOP. Next. Yeah. Here, for the maize experiment, this season we are starting droplet deposition and control effect of pre and post emergent herbicide sprayed with an agriculture drone for weed management in maize crops. There was no work has been done. So we are initiating again in the Honaville research stations. Luckily, university has funded for this project. Yesterday only I got the funds. So this is next please. Again we are doing the swap pits. Next. So this is the treatment details. You can see. First one is drone flying out. Okay. 2 meter above the crop canopy, 3 meter above the crop canopy. Then the spray volume 25 as well as 50 liters. Based on the canopies, we have taken 50 liters. Here 25 liters, which is the standard, that is 10 liters per hectare. You can see we have taken one topromazine. Another one is tombitron. They are the two popular molecules in maize right now. So we have reduced this one. Now if I get some good, because here the treatment comes to around 16. 16, it will come to 16. That's what. See filler trial alli how we will be doing ground level bere crop canopy maize alli variations agutte. See, because every year they are releasing one hybrids with the different orientations of the leaves. For example, now when we are at the kid, the leaf orientation of the maize was different. But now the leaf orientation is entirely different of the maize hybrids. And now the seed count basis they are selling the maize. And the little bit even closer spacing. Earlier it was 60. Now it is on 30 centimeter maize. Closer spacing is coming. We have to calculate all, not only the, see, when you are considering the height or the water volume, we should go for review of everything. In general, 60% what in it they are adopting, you have to consider for calculation. That is the very, very important criteria. When you are planning, don't go for random. Go for some reviews, what they have done. So if you are still bit confused, have a factorial drone flying with the ground, how much of dispersal will be coming out, discharge will be there. Okay, based on the crop, how much it has been deposited, that has to be calculated. Okay, but here, anyway, I'm doing for only with respect to the herbicide. So that's why the crop height, we have taken only 2. So if it goes with the insecticide and pathology, I don't know. Again, the crop height variations and what should be considered, that we don't know. Because that is what herbicide, that's what we were taken only. Because water volume will be less, no? See, here weed check, weed free and the recommendation will be there. Okay? Here, yes, you are right, 1.5 volume. But the water volume is less, no? That's what we want to, that's what we are evaluating. See, you are comparing with the knapsack sprayer, 1.5 ml is high. I have increased the logarithmic scale. Now I got, so when I know that 2x is performing well, immediately I reduce the treatments from, instead of calculating 0.5, 0.75, 1x, 2x, 3x, directly I went for 2x levels. No. Already it has been evaluated. No phytotoxicity. That's all. Already, when they have registered the molecule, no phytotoxicity at the double the dosage. That's what we have taken in the drone. These are all these two are the new generation herbicides. Presently in the market, maize market, everything. Because whatever all the new, even though it is in the market, means already those are evaluated and tested in the university and endorsed. That's what if you are taking means again my treatment goes to 25. Then 2 acres plot. It will mixed. It will be generally it will be there. ಮಾಡ್ತೀವಿ. That will become common. Because main molecule is tombetron and as well as topramizan. Similarly, we have planned for the soybeans. Okay, pendimethalin and as well as imidacloprid. Okay, pre and post emergent. And for PhD students, we are doing for the, particularly with the nanonutrient molecules. And also, we are doing with the foliar sprays with pulse magic and all those things. Now the experiment has started now. Okay. ಪ್ಲಾಟ್ ಸೈಜ್ ಕಡಿಮೆ ಮಾಡಿದ್ದೀವಿ ಸರ್, ಈಗ ಪರ್ಫೆಕ್ಟ್ ಆಗಿದೆ. ಸೊ ಹಂಗಾಗಿ ಪ್ಲಾಟ್ ಸೈಜ್ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ದಟ್ಸ್ ನಾಟ್ ಎನ್ ಇಶ್ಯೂ. ಎಸ್ ದಿಸ್ ಈಸ್ ದ ರೆಕಮೆಂಡೆಡ್ ಡೋಸ್. ಓಕೆ, ದಿಸ್ ಈಸ್ ದ ರೆಕಮೆಂಡೆಡ್ ಡೋಸ್ ಪರ್ ಲೀಟರ್. This one? That is knapsack sprayer. Then immediately we have then we have increased to 0.45 ml. This is 1x level. This is no. These two are 1x and 2x. 1x means that is the recommended dosage is there, no? With the knapsack sprayer. Yes.
So what we are doing, we are calculating per acre and we are paying the acreage dose in 10 liter in that area.
No.
Actually, active ingredient actually
You have to consider. Yes.
they are converted into liters.
Liters only. CAB is, that's what. CAB rule for what? Insecticide, fungicide. There is no CAB rule for herbicide. No. No. They are not listed for the herbicides.
Every chemical has the dosage as per the active ingredient per hectare.
Absolutely you are right. Absolutely you are right. But with respect to the herbicide, when it is applied for the soil, they are not yet declared. Only the foliage based application is they have mentioned. As for my report, if that was the there, definitely we can consider that. But right now, with respect to the soil application based drone applications, because it is directly contacting like that, what the CAB was told, that's why the regulation has been hold for herbicide. That's why, see, in the farmers, they are doing only the foliar nutrition, insecticide and fungicide. In the farmers field, they are not doing the herbicides. Don't know, but it is against the CAB rules, against the CAB, 100%. Yes. No, even for insecticide also there is no recommendation. Listed, but that was not recommended. Correct. Correct. See, even I am in the KVK, so they have listed only the molecules. They were told that this much dosage you should use. Where they have given? That is what SOP. We have to evaluate it. That's what, see what in our Atari zone, what they have said. You go with only the neem oil, you go with only the water soluble fertilizers. You don't go with the other molecules. Yes. You should not use the molecules even though if it is listed in the CIBA. Because some public has given notice means then it will be scientific body, it is problem. We have got the strict guidelines from the Atari. You should not use the insecticide and fungicide even though it is recommended in CIBA. No. We have received Atari. Both are in Atari 11. They are told you should use only water soluble and neem oil. If you are using, for example, if you are using chlorpyrifos, how much dosage you will take? Where it is there? It is not there. You see that. University packages you can take. That's what. There is an ambiguity in that report. That's what. That's why our Atari has given strict guidelines. Don't go with the insecticide and all our 41 KVKs, out of which 10 KVKs what we have received with drones, we should not go.
1x ಅಂದ್ರೆ 0.19 ml ಅಂದ್ರೆ 2x ಅಂದ್ರೆ ಅದು 0.38 ಆಗಬೇಕು.
ಅಲ್ಲ 1.5x ಅಂತ ತಗೊಂಡಿರು. So we have calculated that one. That 1.5x we have taken.
If there is a recommendation of other universities, so we can go,
Huh? No. Region based, that is recommendation. That cannot take the blanket recommendation. Everything. All the recommendation is only regional based.
Only we are going for seed variety evaluation or seed variety new variety demonstration.
No, sir.
Released by other universities.
I agree, sir. I am not telling the crop. No. Species varies. Dosage varies. With respect, because I will tell you, sir, pendimethalin in pulses, even though if you are going up to 6 ml, it will work. In cereals. But in pulses, 3 ml is toxicity. Pendimethalin. Cereals also is sensitive. That's why it is. Sir, all the recommendation of the pesticides is a reason based. And that's what variety, sir. That is what. Sir, you can use the molecule. You can use the molecule, but dosage. You have to calculate. That's what we see. Whenever we are taking the spray schedules, we are taking the pre-disease counts. That is what we are doing. In some cases, in the early stages, if it is high means, they go for higher recommendations. I will tell you, for example, mineral nutrition, it is, they have mentioned. Let me take the example of the nano urea. Okay, what is the recommendation? No, they have given 2, 3, 4 ml. For your region, which you will be evaluating? When I went through the nano urea report, in North India, 2 ml has given very good performance, 4 ml has given toxicity. In our region, 4 ml itself is not worked. That's why they have given the dosage even in the label tag, they will be giving 1 ml to 3 ml, 2 ml to 4 ml.
Foliar nutrients definitely it will vary.
Vary, sir.
Based on their foliage, growth, everything will be
Ah.
because in indoor soybean growth is different and village is different. But for I am asking about insecticide diseases, can be
ಇಲ್ಲ ಸರ್ ಪ್ಯಾಕೇಜಲ್ಲಿ ನೋಡಿ ಆಕ್ಟಿವ್ ಇಂಗ್ರೀಡಿಯೆಂಟ್ ಮೆನ್ಷನ್ ಮಾಡ್ತೀವಲ್ಲ, ಅಲ್ಲಿ ಆಕ್ಟಿವ್ ಇಂಗ್ರೀಡಿಯೆಂಟ್ ಮೆನ್ಷನ್ ಮಾಡಿದಾಗ ನಾವು ಎವ್ಯಾಲ್ಯೂಯೇಟ್ ಮಾಡಿದಾಗ ವಿಲ್ ಬಿ ಗಿವಿಂಗ್ ಫ್ರಮ್ 3 to 6 ml ಯು ಕ್ಯಾನ್ ಯೂಸ್. ದಿಸ್ ಮಚ್ ಆಫ್ ವಾಟರ್ ಅಂತ ಕೊಡ್ತೀವಿ ನೀವು.
ಇವರು ಫಾರ್ಮರ್ಸಿಗೆ ಈಸಿ ಆಗಲಿ
ಸರ್ ಸರ್ ಪಿ ಒ ಪಿ ಹೆಂಗಿದೆ ಗೊತ್ತಾ ಸರ್, ಒಬ್ಬೊಬ್ರು ಒಂದೊಂದು ಮಾಡ್ತಾರೆ. ಇನ್ ಒನ್ ಯೂನಿವರ್ಸಿಟಿ ದೇ ಆರ್ ಟೆಲ್ಲಿಂಗ್ ದಿ ಯು ಡೈರೆಕ್ಟ್ಲಿ ಗೋ ವಿತ್ ದ ವ್ಯಾಲ್ಯೂಮ್ 3 ml per liter. In some university you should tell the range 3 to 6 and also the water volume 100 to 120. Don't give the you give the range.
ಬಟ್ ಯಾಕೆ ರೇಂಜ್ ಇಟ್ಟಿರ್ಬೋದು ಅಂತ ಅಂದ್ರೆ ಅವ್ರು ಥಿಂಕ್ ಮಾಡಿರ್ಬೋದು ಅಂದ್ರೆ ಮೋಸ್ಟ್ಲಿ ಡೋಸೇಜ್ ವೇರಿಯೇಷನ್ ಇರುತ್ತೆ. ಒಂದು 5 to 10% ಎಫೆಕ್ಟಿವ್ನೆಸ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಈ ಫಾರ್ಮರ್ ವಾಂಟೆಡ್ ಟು ಕಂಟ್ರೋಲ್ 100% ಇನ್ಸ್ಪೆಕ್ಟ್ ಆಫ್ ಯೂಸಿಂಗ್ 0.3, if he is using 0.35, he is controlling some 5 to 6% extra effectiveness is there. That can be given as a range. If he can use 0.35 also, 0.3 also, 0.4 also. But as per BC ratio, they might have given 0.3 earlier one.
Maybe sir. What parameters they were considered we don't know during that. Now in many of the this one they have started for ranging. Sir earlier any questions? ಹೌದೌದು. We are considering only the active ingredient. Water volume varies, but many of the in herbicide trials, if it is pre-emergent means it should be 100 to 120 liters. If it is post-emergent, 150 to 170 liters. Not reviews. As for the herbicide label, pre-emergent 100 to 120 liters, post-emergent 150 to 170 liters per acre. So that is what, sir. What they have evaluated again for the marketable issues, they might have go for even 7 liter, 8 liters also. Same chemicals. Right? If no doubts, we'll break for lunch. Then afternoon is flight planning and the demonstration of flying the drones. Okay? So we'll complete maximum by 3:30. So we'll take a break. So tomorrow we have to leave little bit, start our journey by 5:30. 5 o'clock vehicle will be reaching in front of the guest house. So 5:30 we're planning to leave. Okay, fine. Thank you.
ಇವತ್ತು ಬರಲ್ಲ
ಅದೇ ನೆನಪು
ನೋಡು ಇವತ್ತು ಬೇಕಾದ್ರೆ ಬೇಗ ಬಿಡ್ತಾರೆ
ಎವ್ರಿ ಟೈಮ್
ಹಾಂ 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 ಅದೇ ಅದೇ ಏನಿದೆ ಅಂತ ಬೇಕಾದ್ರೆ ಮುಗಿಸ್ಬಿಡೋಣ ಸರಿ ಬೇಗ ಬಿಟ್ಟರೆ ಅದೇ ಮುಗಿಸ್ಕೊಂಡು